Morning, Martin. Okay. Right. So, yes, welcome to the last day of Data Science Africa 2021 at SPU. It's been a long, I hope quite fruitful 4 days. This is the last day, the second day of the workshop. I see the numbers are a bit low early in the morning for some people. I think we should still go ahead. Martin, how are things in Uganda?
Things in Uganda are fine.
Okay, I also, I think we should go ahead, Martin, right? See, Peter, you're our first presenter. Maybe we can just, let's start at 9:05. Maybe if there are last minute people joining, then just you can set up your screen, and then at 9:05, you just get started. Thanks.
All right, no problem.
Yeah, feel free to do whether video or not. It's up to you.
Okay. All right. Thank you. Could you please allow me to share my screen?
Hello, Martin.
Yes.
You can share now.
So it's not Martin, but Peter who is presenting. So yeah, they can now share.
Okay, thank you. Okay, good morning, everyone. I think I'll just start now. My name is Peter Uporla. I'm running on my PhD studies in computer science in the University of KwaZulu-Natal. I'm happy to be here for the workshop, and I hope that the time we'll spend together will be beneficial to all of us. Okay, so today I'm presenting on techniques for proper missing data treatment, and the time is short, so I'm going to kind of be a bit fast. Okay, so basically missing data is a problem or a challenge that is faced once you want to deal with real life data. You're going to face the issue of missingness of data, your data being missing. So that occurs when your data is, some part of it is unobserved. That means you don't see some part of the data, you're not able to get it, or it's not available. For example, you do a survey, some people do not respond to one or two questions, or you're in the lab and maybe you've set up your lab to do a long series of experiments, and then due to some arbitrary malfunction, some of the data points were not computed, or invalid values were generated. When the values are invalid, it's different from if they are just like outliers. For example, this is just a very simple example. If you have maybe an age that is negative, that's not an outlier, that's an invalid value. So that's seen as, that's a missing data, because you're going to have to delete that, remove that value, because it doesn't make any sense. So, so that's another case where that you usually find missing data is when you do longitudinal studies. So that's studies that continue over a long period of time, repeated measurements over time. You want to test the impact of something over time and all that. So when you're doing those kinds of experiments, there's a tendency, especially if it's like you're in the medical field or in some other field, the respondents, if you have like people that are coming for measurements over time, maybe you take their blood pressure, you take this measurement and that, over time, there's general tendency for the number of people that turn up consistently to drop off. So that's attrition. So that's another case where missingness occurs. So now in your data set, you could have missingness in just one variable. It could be in multiple variables, or it could be monotonically. So when you say data is missing monotonically, what we're saying is, once you find, let's say you've set up your data set like this, you have your columns like this. And these are the rows, right? So once there's missingness here, once this variable is missing, every other one is going to be missing. Let's say in this case, you have 1, 2, 3 points. Once this part is missing, every other one is going to be missing. So that's monotonically missing. If there's a way you can arrange the variables such that you form a staircase pattern, then the data set is said to be monotonically missing. Okay, so let's just move on. Okay, so I'm going to give just, we're going to look at the different mechanisms by which missingness occurs. So I'm pretty sure I saw in, I think, one of the first lectures, so someone touched on this. So I'm still just going to cover it because it's pertinent to what we'll be talking about. So there are three mechanisms. There's missing completely at random. With missing completely at random, the probability of a data point being unobserved is purely random. So, and then the likelihood of missingness is the same across all variables. So there's nothing in a variable that influences, in the nature of a variable that influences the chances of data being missing. So it's purely random. So that's missing completely at random. Then missing at random, in the case of missing at random, the probability of the data points or of a data point being missing depends on the data that is observed. So if you have a variable where there's missingness, what we are saying is that there are some other variables that can give you some information about why that particular observed, why that particular data point is missing. So that's missing at random. There is some information within the data set that can tell you more or give you some information about where. So, but when you come to missing not at random, sorry, this should be not. This is not missing not at random. then the missingness is, so basically you have a variable where the chances of the data being missing depends on that variable itself. Okay, it depends on the value. So I'm going to give examples now, just so that we can be able to relate with this more. So for example, if a missing completely at random condition can occur when a correspondent mistakenly skips multiple questions in the questionnaire. You know, that's just a random occurrence, and nothing can be attributed to that. You know, or a laboratory device laboratory malfunctions. I've already talked about that. Or a data collector enters invalid value. Okay, so human error. Someone is typing in your data. Maybe you've done your experiments and you ask someone, please help me to put these things in. And then the person mistakenly puts invalid things or even skips some of the values. That's completely at random. And there's a statistical test that was proposed by Rubin, I think around in 1980s or so that you can be sure, because missing at random is actually one of the most desirable missingness mechanisms. When you have missingness, if it's missing completely at random, it's easier to deal with. Okay. Then we have missing at random. So basically missing at random, some examples, the participants being removed from a trial if their conditions are not controlled sufficiently according to protocol criteria, or dropout based on recorded side effects. So you can see that these things are part of the data. So the side effects that are recorded are in the data set. So when we look at the data set, we can see, oh, the people that had these side effects are the ones who are dropping off. So those variables, by the time we look at them and then we perform some computations on them, they can help us to guess what the data that are missing are, what the missing data points are. Okay, so there are many treatment methods. Actually, most of the treatment methods, the existing treatment methods in the literature assume missing at random. They assume a missing at random. And for most data sets, you can also assume missing at random, because missing completely at random is a bit stringent. It's a bit stringent condition. You can assume missing at random when you're trying to handle your missingness, but it's important for you to report how your data was collected. So you must report how your data was collected, as well as when you're treating the data, try to include as many auxiliary variables as possible. So, you know, when you add more variables, then the chance that you're adding a variable that can tell us, that has information about why that data set is missing is higher. So that's why it's recommended that you add more variables to the imputation model. Okay, so the last one, missing not at random, is very difficult. So just simple example of missing not at random. You're trying to collect income of some in your data, in your questionnaire or something. You're asking people to give you their income, and those who are earning a lot, you know, they're probably less likely to answer that question. But you're not aware of that. We're just doing this as an example because now we know. But let's say you're not even aware that it's because they earn high that they don't supply the information. So you don't know, you have no information about why those income, but there is a pattern to it. Understand? So it's not just that you don't know why, there's an existing pattern to the missingness within that variable that you don't know, and that no other variable can tell you about. So that's missing not at. Okay, let's really go to how to treat the missingness, because I'm trying to be very conscious. Okay. So methods for treating missingness. One of the most common methods, easiest and sort of most common, is deletion. So there are two types of deletion. There's case-wise deletion, where you just delete the entire observation. Once you find missingness in one variable or the other, you just wipe out the entire row, the entire observation. Or pairwise. In the case of pairwise deletion, what you're doing is, for example, you're trying to do correlational, you're trying to calculate correlation between two variables within a data set, right? Or you're trying to calculate the correlation matrix, right? So pairwise deletion, when you're calculating pair between two variables, you're going to delete all the unobserved ones just for that particular computation. By the time you're done, your data set is still the way it was. When you pick the next set of pair of variables, you delete all unobserved again. So that's something that's sort of, we could say maybe better than this one, but it's also used in many of these implementations that you have in statistical packages. Okay, so when the data set is missing completely at random, you can use this case-wise deletion or deletion method in general, but you must do it only when you have very low missingness. When the missingness is very low, that's when you're allowed to do that. The higher the missingness, even if you have if you can prove that you're missing completely at random, the statistical power is going to reduce. So the statistical power is going to reduce when you delete. I'm pretty sure if you have a data set that's like 10,000 and you delete 4,000 or 6,000, then the statistical power associated with your results will be reduced. But if you are not able to, if you cannot guarantee this mechanism, then deleting is very unwise, because it will introduce bias into your data set, and then your results will be unreliable. Okay, so then we talk about imputation. So there are imputation methods. So there are three methods. There's deletion. There's deletion, there's imputation, and there's direct estimation. And there's direct estimation. Okay, so under imputation, you have single imputation and multiple imputation. I want to give you a top-down view of this. Okay, so under single imputation, you have these types. So basically, imputation, you're doing an intelligent guess to replace the missing data. You're trying to make an intelligent guess. Okay, so you're trying to make an intelligent guess. Sorry, just a minute. Okay, so sorry for that little break in transmission. Okay, so when you're doing single imputation, basically you're making an intelligent guess to replace the missing data, right? Okay, so there are various methods for single imputation, but the more intelligent, so the more you want to be accurate in your guessing, the more complicated the method that you're using is. Okay, so some of the popular methods, you have mean imputation. So basically with mean imputation, what you're doing is that for each variable, you calculate the average value, and then wherever there's missingness, you impute, you just put the mean value in that missing position. But that method is quite, not good, because it will alter the data distribution, right? It will shrink or just change the distribution, and because the spread and all that will be affected. Now you're basically constraining the data set to the average. Okay, and then you have hot deck imputation. You create a pool of donor records, and the selection of what constitute the donor records will determine, is the method you use determines the variant, right? So there are many variants of this hot deck imputation. So basically you have a pool of donor records, and then you pick out of those ones from the existing data. So some of them use nearest, try to find some metric to compute which of maybe n nearest observations to the one you're trying to impute, and so on and so forth. And then out of those n, how do you select the one that you're going to use? So there's very simple hot deck imputation that everything just random, and there are more intelligent ones. The more intelligent it is, the more time. Okay, then we come to regression. So regression, basically what you're doing in regression is that you're trying to make a prediction. Remember, with the imputation, we're trying to guess. Okay, so you're trying to make a prediction based on the information in other variables. So you regress the other variables against the variable that is with missingness. And then, so you use those variables as predictors to create a regression model, and then you try to predict. So there are various ones. I'm trying to finish quick now. Okay, there are various ones. So, but just to keep in mind that it has a weakness. So when you're doing regression, there's a chance that you're going to predict a value that is invalid. Okay, for example, we said maybe age that's negative or height that's more than 3 meters or something like that. But there are some approaches in literature that you can use to correct those or repair those invalid values. Predictive mean matching is sort of a hybrid between regression and Bayesian inference, where you're sort of, it's like you're doing regression, but you're only using existing data. So that thing of doing invalid values will not arise. Okay, let's just quickly move because time is running out. Okay, now multiple imputation is the state of the art, right, for treating missingness in data. Multiple imputation. In multiple imputation, you're imputing multiple values for each missing point. So let's say you have a row, right? A row, 1, 2, 3, 4, 5. Now, if this, let's say you have values here, 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 but there's nothing here. So this place is missing, right? In multiple imputation, you input m value. So you're going to guess more, m, whatever the value of m is, maybe 5. That's like the default. So you're going to guess 5 values using usually regression or something. So you use regression to predict 5 values for this part. So what that does is that the uncertainty that's associated with the guesses you're making is sort of taken care of, because now you have a range of values that you're going to sort of try to average against. Okay, so basically there are 3 stages for multiple imputation. You first impute. So like I said here, you do your regression m times, and then you get these guesses. And then now what you're going to do is that when you input m times, you have multiple cells like this that are missing. So what that's going to lead you to is you're going to have m data sets where you have these different values that are imputed, right? So now you're going to analyze each of those data sets independently. Okay, analyze them independently. And then when you've analyzed them independently, let's say you want to calculate, you want to do t value or ANOVA or whatever it is, you do it on each of them. Then now what you're going to do is that you pool. So there are some methods in the literature. I've put some references at the end that you can also check out. You pool. So you try to you can try to do average or study of those target metrics, right? So you try to do a pooling. Okay, right. So this is the state of the art for doing missingness imputation. Okay, so there are some popular methods for multiple imputation. You have mice, you have expectation maximization, and these methods they are implemented in various libraries in Python R. So you don't need to concern yourself too much about, oh, how am I going to implement this? There's good libraries in R, there's good libraries in Python and SAS that do this, that are already done for you. You just need to read the documentation so you know how to use it. Okay, so some quick tips, and then I'm going to just do a little demo for you to see the impact of the methods you use for imputation with some graphs, and then we'll be done. Okay, so when you're trying to do imputation, your predictors that you choose, remember you're doing regression, the predictors you choose very important. Okay, so try to, the more predictors you have, the better, but if you have too many predictors, you're going to introduce noise and the model will be weaker. So choose a reasonable number. Try to, when you're choosing the predictors, try to make sure that you get those that are more highly correlated. So you can have a correlation matrix. Choose the ones that have higher correlation with the target variable. It will give you better predictions, better imputation. Okay, so another thing that's very important, I'm just going to skip the other ones. You can look at them. I'm pretty sure we'll be able to have access to the slide later. Is, so in your data set, sometimes you're going to have some variables or columns that are sum scores or they are derived. For example, you have BMI, right? So you have BMI, you also have height and weight, weight, right? BMI is a product that is computed using height and weight. And when you're doing your imputation, you must skip this BMI, right? You must skip, don't impute BMI, impute weight and height alone. Then post imputation, do the computation again to derive this one. Because if you try to impute this one, the relationship between these two and this one will be disrupted. So that's why you don't impute you don't input those derived values. You impute only the independent variables, and then you do the other. Okay. So if you have higher correlation in your data, it's kind of good for imputation, and you try to validate your imputation. Try to check the distributions and see. So that's what I want to do now quickly, just so you can see what I'm talking about in practical terms. Okay, so I just did a simple graphing of some of a data set, just one variable. Okay, so I'm just quickly going to show you. We're going to start with missing completely at random with different levels of missingness, and you see what I'm talking about. So I use complete case analysis. This is just deletion. So you delete anything that's missing, any row that's missing. This is the original data set. I would have actually shown you the original distribution, but you can see from the shape here that this is the shape of the distribution for the full one. And then you have mean imputation, and then you have regression. So regression is basically single imputation. Since I'm showing you a distribution here, I can't show you for multiple imputation, because you have multiple data sets. You only have the impact on the target metric. Okay, so but single imputation regression is also kind of good. You can use. Okay, so you can see the distribution here. You can see that even at 0.05, in this case, the mean imputation is already disrupting the distribution. Okay, but let's go to 0.25. You can see that when you do mean imputation now, the distribution is already going very, very wrong. It's very wrong. Okay, now this is the original distribution, as you can see with the blue line around it. So this is the original distribution, right? You can see that regression, even at 0.25, regression imputation is still close to it. But when you do mean imputation, which a lot of people do, you've really changed the distribution. Now it's already multimodal. See, the original distribution is kind of unimodal here, but with mean imputation now, you already have a multimodal distribution. And the position of this mode is already different. So the distribution has been changed. So automatically, any inference you make from this data set is going to be wrong, right? So, and you see the effect more. As the missingness rate increases, you can see that the data is getting more and more distorted, right? But for regression, you can see that it's still very close to the target. You can see that if you do deletion, like we said, the power is reduced. You can see that the power is reduced. Now it's lower here. And so the distribution is also changing, but it's not as pronounced as this mean imputation. Okay, and so on, it continue like that. Now with higher risk, you can see that the other ones are also failing more. This is the target distribution. You can see the other ones are also failing more as you go. So when you have very high missingness rates, you're going to see your imputations getting worse and worse. Okay, so same thing with missing at random. You can see, I'm not going to spend a lot of time here, but you can just still see the same thing happening. Yeah, so that's it. I'm just not going to spend too much time here. You can see the same thing. Just observe that, sorry. Another thing I just want to observe here is that you can see that the best method is regression, right? When you do regression, it's the best because it stays closest to the original distribution. When you look at them, even complete case analysis, when you delete, you see that it's farther away from the target. Okay, this is the target, this is your regression. Okay, and you observe like that, you continue seeing that same pattern repeating itself. Okay, so let's come to missing not at random. That's why you're going to actually see this very, very, very much clearer here. Okay, same thing, you can see this mean thing is just really bad. Okay, okay, now let's come to 0.5. You see it's bad again. You can see this is your original data set. You can see regression is still sort of close, and complete case analysis is farther away. Okay, so that's basically, and then you can see, so this is basically the target slide we want to go to here. So we have missing not at random, and you have 0.75. So we stopped at 0.75. Now you can see complete case analysis is very poor. Imputing mean values, very poor too. But then you have regression, and this is the original data set. So you can see that these are closer. So basically what we're just saying in conclusion is try to, try to be more intelligent with imputation. Okay, so don't just, when you have a data set and there's missingness, just delete it. Try to be, try to use some of these existing methods to do imputation so that your results can be reliable, right? So that your results can be very reliable. Thank you very much, and I'm sorry for shooting above the time a little bit. Thank you for the opportunity.
Thank you very much for that talk, and we welcome questions in the chat, or maybe one person, if you want to unmute and ask any question. Let's also show appreciation to the speaker. Thank you very much. Questions? I'm curious whether because that sequence of simulations is very interesting. I'm wondering if you have the code somewhere, somebody can reproduce it for themselves.
For those graphs. Hello. Hello. Can you hear me, please?
Yes, for the graph. Okay, so
you're asking for the code for the graphs, right?
Yeah, I found it quite fascinating. I think it would be instructive. If I was just asking if it's available somewhere.
Okay, I could probably try to make it available. It wasn't easy to generate the graph, but I could try to make it available, at least to some extent. Yeah, but it's in R anyway, so the person probably have to know R.
All right, thanks. There's a lot of appreciation on the chat. I don't know if I see any questions. In the meantime, we can also have our second speaker getting ready to present.
Okay, thank you very much.
Thank you. I believe the next speaker is Ms. Njiwe. Are you on the call? Are you online? I see you.
Yes, I am online, sir.
Okay, so you can be able to share your screen for your presentation.
Yes, of course. I will be able to share my screen and my presentation. Okay, let me just share my screen. Okay. All right, entire screen, share. Okay. Is it visible?
Yes. Oh, okay.
Okay.
Though I don't see any presentation yet.
You don't see a presentation? How about
no.
It's about to start now?
Okay.
Yeah. It's a bit rainy in South Africa, so the network is not too good. Is it okay?
On my end, I don't see anything yet.
Nothing yet. On my side,
Nothing
it
yet.
says share screening, you screening and sharing. So I don't know. Let me start over
I think
again.
it is trying to. I think it's trying to load.
Oh, okay. It's trying
is slow,
to load.
but yeah. Mm.
Okay. That's fine. Please let me know if it's visible, when it's visible.
It is now.
It is. Okay, then.
Yes.
Okay. So for our talk today, we're going to be talking about recommender systems. So basically, before we get into the recommender systems, a bit about me. Who am I? So I'm a senior software engineer at Amazon. I'm also an interview engineer at Carrot. My main focus is system architecture, system design, Apache Spark, big data, and recently machine learning and AI. So if you want to get hold of me on Twitter, that's my handle. Medium, I also write a few publications about system design and all the infrastructures, and then on LinkedIn. So yeah, let's get started. Okay, so for our agenda today is basically like an introduction to recommender systems, okay? I'll just brush up a bit on the content-based filtering, the collaborative filtering, and matrix factorization. So I'll mix both together. I'll get into recommender systems using Surprise and Keras frameworks. And then, yeah, we can conclude our talk. The reason why I didn't use Apache Spark, because Netflix, we use Apache Spark for is because it's a bit complicated. So I feel like as you getting into recommender systems, you can start first with Surprise, which is a bit easier, and Keras. So the whole of the Netflix system runs on AWS, Amazon Web Services. So the whole of the backend, right? So we're just going to be focusing on there, like the recommender on the machine learning part of it, and not so much on storage and everything, but just the recommendation part of it. Okay, so we've all had an interaction with a recommender system, be it on social media, like on Facebook.com, it would be suggesting friends to you, on Netflix, suggesting series and movies, on Amazon.com, suggesting items, right? On Spotify, music, on iTunes, and so on. So it's very important for the system to get it very right. You cannot be in a situation where you recommending wrong content to a user, right? The whole aim is to keep them inside the platform for as long as possible, right? So recommender systems are quite profitable to big tech, basically, the FANGs. For Amazon, it counts Amazon.com, not AWS. For Amazon.com, it generates 30 to 35% of their revenue. And for Netflix, you're looking at 70 to 80%, same as Spotify. So it's quite crucial, the recommender systems, and they're playing a big role now. They basically like running a business. Netflix, you can tell Netflix has one of the best recommender, not Netflix, I meant to say TikTok. TikTok has one of the best recommender systems in that it keeps the user there longer than Instagram does and Netflix does. So so they're quite very important, and it's quite an interesting research margin. Okay, so the artwork. So as you come into the platform of Netflix, right, you given an artwork that is styled specifically for you, right? So I'm a bit more of a thriller, psychological, horror, sci-fi fan. So maybe mine would show as I go in, because I don't watch Netflix. So don't get me wrong. I'm a bit busy, so I can't watch Netflix. But let me say, if I was a binge watcher of Netflix, then it would recommend to me like your Stranger Things, Daredevil, Orange is the New Black. And as you see, this artwork is more for drama side. It shows you like crime drama, Narcos. Daredevil is a bit of an action. Orange is the New Black. So it's important to style it how the user, particular to a user, right? So that the user can choose there, okay, maybe today I feel like House of Cards. Okay, maybe Daredevil. Now, if you're gonna send Saw and other slasher gruesome kind of films to a sensitive person, that person is gonna exit immediately. So how do you get it right? How do you get that artwork and the recommendation right? So before we go into the whole algorithm and the practices, I'd like to go a bit on how recommender systems started. So there's a bit of a history. They've been around for quite some time, but most significantly, we had collaborative item-to-item filtering at Amazon.com, which was recommending items to people. So that's the most significant use of recommender systems before they went big and before they went so commercial. And then Netflix ran a competition where the bounty was like $1 million. And they said to people, okay, make our recommender better, make it better, and you will win $1 million. So now not only one person won, quite a few people, quite a few amount of people won. So that led to a whole research in the new ways we interact with recommender systems, deep learning, and reinforcement learning when it comes to recommender systems. Yeah, so we started off with content-based system. So when Netflix first started off, there was where the user could fill in, okay, all right, what kind of a movie do you like? Okay, so like Tenji likes Saw. Okay, Tenji definitely likes Saw 2. So maybe Tenji would like Saw 4, all right? So, but that's not how it works, basically. Because people do change. I would like Saw 1, 2, and 3, but maybe I wouldn't like 4. And people weren't good at saying that what they like and what they don't like. So now we had content-based and we had collaborative. Now, content-based was based on that, on what do you like. So if Tenji likes this, then it means that Olerato would like this. But based on such, that that model was not too accurate. So what came up was that, okay, let's take the features, right? The features would be horror and drama, okay? So we're gonna start pair the features with the user and the series itself. So we have Tenji, né? Tenji likes horror, okay? But doesn't like drama that much. So we can give horror a rating of 3, okay? And drama a rating of 1 or 0, okay? And then now let's pair the features with the series itself. So The Walking Dead, it's quite an horrific movie. So we need to give it a 3 when it comes to horror. And drama, yeah, there's a bit of drama. So maybe you can give it a 1 in terms of drama. So that's how we'd pair it. Now, coming to Lerato. Let's pair Lerato. Before I get to Lerato, now, the rating that Tenji would give to The Walking Dead, right? Because we know that Tenji doesn't like drama very much, we ignore the rating we gave on drama and we just take the horror one. So Tenji would give The Walking Dead a 3. Okay, so now moving on to Lerato. Lerato loves both horror and drama, both. So we can rate Lerato to horror 3 and Lerato to drama 3. So that would give us a 6 when it comes to Lerato and drama, right? Now, in terms of The Walking Dead, okay? The Walking Dead, as we said before, it's more horrific. It has a rating of 3, and drama, it has a rating of 1. So with Lerato, we don't ignore anything because she likes both. So we just tally up the 3 and the 3, it's 6. So The Walking Dead has 6 from Lerato. Now, there's Mawande here. She doesn't like horror very much. So we need to give 0 in terms of horror to Mawande. But pairing Mawande to drama, we can give it, she loves her drama very much, a 3. Okay, so let's check The Walking Dead. We said it's very horrific and quite dramatic, but not that much, it's 1. So we're gonna ignore the horror one because Mawande doesn't like it. We don't wanna recommend something she doesn't like. And we'll just take the drama, Walking Dead to drama, which is 1. So the rating for Mawande to The Walking Dead would be 1. So this is how we were rating at first when it comes to content-based. And this wasn't quite an efficient method. So we needed something more accurate to go forward. This led to collaborative matrix factorization. So what is this? What is this big word? Factorization, matrix factorization. So going back to basic maths, factorization, 5 and 3 are factors of 15, right? So matrix factorization is a matrix of something, and a matrix of something is a factor of something, right? Okay, in our case, it's the big matrix. So it's the factor of the big matrix. So it's basically breaking down the big matrix into smaller matrices, right? So in our case, we have one matrices, that's the number of users, and then the other matrices, that's the number of items. We times this together, this gives us the big matrix, right? This is how we would work in matrix factorization, basically. So breaking down that big thing, yeah, on how we rate and factor and make it into smaller parts. So here's how we would represent it as I was doing it earlier on. So we start with the series itself. Then we give it the features, right? The Walking Dead, it's very horrific. We'd give it a 3. Drama, we'd give it a 2. But I said earlier on 1, but it's okay. So Money Heist. Money Heist, no horror at all in Money Heist. So no need to give it a rating of anything when it comes to horror. But it's very dramatic, so you can give it a 3. And then Bird Box. Bird Box is a bit of both, horrific and dramatic. So you can give it a rating of 2 when it comes to horror, and a rating of 2 when it comes to drama. Okay, and then feature, right? Users is to feature. Now, our features is still horror and drama. And then we have Tenji. Tenji loves her horror, so we give it a 3. And then when it comes to drama, a 0. Lerato loves both horror and drama, so it's 6. And Mawande hates horror and loves drama, so it's a 3. All right, so moving on. So we take those 2 matrices we just did in the previous slide, and we make it into the main matrix, the basic one. So this is the factorization. We're talking about the matrix factorization. So we put this as this. So this helps in a way of getting items quicker. So like, let's say in a matrix of 1 million items, so we're looking for something. So the machine is looking for something in a matrix of 1 million items. So we just need to go to the specific blocks of that matrices and find what we're looking for. And in terms of storage, this saves us a lot. Let's say if we were to install the entire matrix within our storage, all these blocks and counting out everything, that would give us maybe 1 million entries or 2 million entries. But if we store that separate 2 matrices, right, separately, that would take the number down dramatically, you know. So the matrix factorization helps in terms of accuracy. In terms of retrieval, it's very fast, the big O notation. And in terms of storage, big O of N, it's quite effective in terms of storage. Remember, in big tech, you want to be very fast. You want to get your information very fast, and you want to store efficiently, because someone is paying for that storage. So you don't want to escalate costs of storage and so on. So yeah, let me move on to the notebooks. Okay, let me just stop presenting here and move on to the notebooks. Just want to move this because I want to stop presenting. Okay, yeah. Okay, just want to move to the Jupyter notebooks. And the notebooks I prepared for you guys. One is purely on the surprise, and then the other one is on carols. Okay, so let me move there. All right. Okay. As I said, network is a bit slow. So yeah, we're experiencing rain. Okay, so I will be using Google Colab. The reason why I prefer Colab more than Jupyter Notebooks is because of the cloud storage. As you can see, I'm also using cloud to present. So as a person that works on and builds most of the cloud a lot, I believe in cloud and not keeping anything like on your device. So Anaconda is quite big. So if you're looking like to save space in terms of storage and so on, there's a GPU that Google allocates to you when you're using Colab. So I think maybe the other speakers were doing on Colab and stuff like that. So here's our notebook. What I will do is that I will push them to GitHub, both of them, so that you can play around with them. I'll also push the data sets which were uploaded by Netflix on all the rating and everything. So I'll push both of those. So, oh gosh, still experiencing network problems. Okay, let me just, yeah, okay. So first, what you do is you install your packages, okay, the surprise package. Yeah, basically that's what you're gonna be using most of the time, numpers and pandas to read our data and to read our arrays for that. And then the data set itself, as I said, I will share it I'll share different types of data sets. I'll just push it, or I'll just talk to the organizers about getting the notebooks and the data sets to you guys, or I didn't attach my GitHub, so I don't know, but I will arrange that at the end of the presentation. So here is the data set. So I don't know if it was discussed during the talks on how to load data on Google Colab, but what you have to do is that you put your data set on Google Drive. So you just upload it, right, to Google Drive. And the drive must be the same name as your Colab. So if the same account, basically. So if you're using Tenjo Kubeka, and the drive too must be Tenjo Kubeka, not two different accounts to log in. And then you're just gonna mount it on and stuff like that. So then you would load the data files, and you would basically like put your data in your frames, your data frames, which, as I said, the matrices we're talking about. So now here we're just using NumPy to make it faster for us. As we know that pure Python is not as fast. NumPy is also has some C abilities, so it's faster when it comes to processing data and stuff like that. So yeah, basically that's what it is. It's quite explanatory. I put everything here in the code. Yeah, so I'll just push it to GitHub or give it to the organizers so that you guys can see everything. So that's it. And here's the second one by Keras. Okay, second one is the Keras one. Okay, so the second one, we basically using Keras, and we also using NumPy. Of course, we will use it. We're also using the surprise model. It makes recommender a bit easier for us, and we have matplotlib just to plot out our performance and our recommender and how our system is doing, so that we can see that. So, but this one, we're using the Keras. So if you don't want to use pure what's the surprise, you can use Keras, which is a bit more efficient. It's a bit faster. So it's up to you which one you prefer to use. But basically, what I do advise is that you can play around with them, both of them, get your feet wet when it comes to recommender systems, and then you can move on to Apache Spark and then build your whole complex recommender systems as you so wish and so on. Yeah, yes. So my presentation is a bit short and brief, only because I have some other stuff to handle if it's not much of an inconvenience. Okay, so thank you.
Thank you very much.
Yes, hello? Yeah.
Yes, I said thank you. Thanks a lot for that talk.
Yeah.
And I'm sure we'll get a few questions in the chat, or we can allow one or two people to unmute and ask directly.
Yes, they can.
Right. So you said you make all the links available so that we can share them with participants, right?
Yes, I will. I will just send you all the links and the data sets and everything that's needed, probably by this afternoon.
All right. A quick question from me as we wait for others to ask. Are there any similarities between how this system work, for example, on Netflix, and how they work on, for example, ride like Uber, or these rideshare services?
Okay, in terms of recommender. Oh, okay, yeah, finish. You can finish.
That's fine. I think you got my question.
Yeah. I was going to ask in terms of recommendation, or in terms of batching and stuff like that. In terms of which algorithm, because
I guess the recommendation,
Uber does,
the matching.
Mm-hmm. What Uber does, it has batching, what we call batching, right? let's say there's 5 of us, right? And we're calling an Uber simultaneously. It does happen, okay? So the Uber doesn't use recommendation at all. It uses batching, okay? So it also is running on AWS, okay? So what would happen is that drivers would be matched according to a batching system, not according to who's nearer. So let's say there's driver A who's nearer to you, okay? And a bit further from me, not too far, but a bit further from me. And then there's driver B who's a bit closer to me, but closer to, at a distance to another user C. All right. Okay, so the whole aim is to reduce the time, the waiting time for all clients, right? So at first, it was like, okay, let's match everyone to the nearest driver. This didn't work in that your nearest driver is near to you, right? And it's not too far from me, right? But the other driver is far from me. So now if we take this driver to you, if the system assigns this driver to you, it means now I have to wait for that guy who's a bit further than me. But if we had used the batching system in which there is an algorithm that can calculate that, okay, we have so many people in the system, so many drivers in the systems, let's calculate and recalculate everything so that everyone has a minimum waiting time. You understand? So now we don't use it according to who's near and something like that. It's a batching system that checks, okay, in terms of distance and waiting time, the net waiting time, how fast can we make it? And how can we make sure that clients are not kept waiting and stuff like that? So that one uses batching. And then the recommendation one is the one that's used for items. But we also use it now for basically, what is this? Recommending loans and everything. But that one's used for loans, you understand? For Uber, we can't use it in terms of, okay, we're going to recommend this Uber for you. Because with Uber, it's not all about, okay, your preferences and what you want. It's about getting you to wherever you're going as fast as possible and not making you wait.
Okay, thanks. There's a question. Thanks a lot. There's a question from Dina. Do you want to unmute and ask it? It's been typed in the chat.
Thank you very much. Thank you for the good presentation. I just wanted to understand whether this the algorithm you shared with us can be extended to other custom data sets.
Yes, it can. It can. The algorithm I shared, you can use it on any data set, courses or what items, shopping. You can use it for anything, basically, the algorithm, but it's not the complex one that you would find in big tech, definitely not, but it's one that would get you started, right? On recommender systems, and it's actually good enough to recommend on a commercial level. It's not that, okay, yeah, big tech, but it can scale on a system and recommend accurately. Basically, that was the aim. The aim wasn't to bring Apache Spark, big recommender system algorithms here and stuff like that. It was to get you guys exposed to recommender systems, and so that you can play around with them, and so that you can put them in your applications and see how they can help your applications in a way, and learn as much as you can and how to better your applications with recommenders and so on.
Thank you.
Okay.
All right, thanks. So thank you. I think you look in the chat. There may be a few more questions coming in. We're ready to have in the next speaker, the team from SPU. I see Eli is on the speaker list. Is the team ready to present? You can share your screen.
Okay. There was just one question here. Just before I go. It says, thank you very much. Tenjio, what is the difference between recommendation system, concept, and reinforcement learning? Basically, a recommendation system can have reinforcement learning within it, right? A recommendation system is basically, as I said, it's to get the user, to keep the user on the platform as much as possible, right? Is to recommend items to them. So traditionally, what you do, this is way before everything went digital, you'd go and, you know, check DVDs and think and ask your friend, which one are we going for? Now, we just automating that task, right? With machine learning and with reinforcement learning and deep learning. And we're making it like the machine would come back and come to me, the machine learning engineer. I'd tell it, okay, machine, please go and apply matrix factorization. And it would go and do a few calculations and come back to me is like, okay, is it between matrix A and B? And I'd be like, no, machine, not yet. And then it would go. It will come back and is it between matrix C and D? No, not yet, machine. So it would compute and compute until it gets it right. And there's no such thing as right 100% accuracy in machine learning. What we do get is, okay, good, you know, accuracy. That's what we can work with. We don't work with 100% in machine learning, even in big tech. So so what it is all about, recommendation systems is about basically automating the task of recommending a movie, you know, to bring that task to a machine. And then reinforcement learning is basically now teaching the machine to get better at the task, because it comes back and asks, comes back and asks, and very faster than I'm even saying it. So it can compute stuff very faster. So I hope that answers you. Okay, so Spark. Okay, how best can one start to Spark on AWS for recommendation? Okay, so you can go to Apache, right? Apache is open source, so you can go to apache.com and you can start to Spark basically. And AWS has a free tier, so you can also do some machine learning and embed your Spark there on AWS, so you can get a free account on AWS basically. So you can go to Apache and you can get started. But before you do get started, I do advise that you go through this, all right, and read some of my documentation, which I'm going to attach. I think I'll add some more stuff here, and then you can get started with Apache Spark, and then you can, you know, have fun with it on AWS. Okay. Yeah, is that all?
All right. I think, yeah, I think for now, we can move on to the next speaker just to, but you can, if there is more interaction, we move it to the chat.
Okay. GitHub. Yeah, I'll share the GitHub link. I'll share the GitHub link. Thank you, guys.
Okay. So yeah. Maybe is Melvin online for the SPU team? Eli, you can stop sharing now, and that will allow the other team to share their screen.
Okay. I don't know. I don't know if I can be heard.
Test that.
Yes, you can.
Yes. Okay.
Okay.
Okay, good morning. Can I test, Chair, if you can hear me?
Yes, can hear you.
Okay, great. Thank you very much, and thank you for joining this session. My name is Mwekezi Musia from the Center for Teaching, Learning, and Program Development. So we want to today talk about one use case that we have. We actually particularly narrow it down to a specific case which we would showcase or talk about. And our real objective, we're not that ambitious, given that we given 25 minutes. So we're hoping that this will be kind of some teasers or starters that would get many people who want to get into the space thinking about what are the possibilities. So I am here with three of my colleagues. So part of what we have in the directorate is a portfolio called Data Analytics, which looks at student data and particularly learning. And I think my colleague will get a little bit more into that at a later stage. So I'm going to just ask them to introduce themselves. Okay.
Good morning, colleagues. My name is Malvin Kirsten, and I'm a junior developer at Soapline University. So I do most of the development stuff and serverless deployments. Thank you.
Good morning. I'm Eli, and I'm a postgraduate student and work part-time as a student assistant, and I mostly handle the dashboard sections of our work, basically creating web applications. Okay, and moving on to the presentation. So we'll be talking about building cloud-based serverless data platform for learning analytics, and we'll just give an overview of what learning analytics is. Okay. Okay, so the takeaways for presentation is basically how simple it is to run on a serverless Django and how simple it is to scale out serverlessly, right? So what is learning analytics, right? So learning analytics is basically just the collection and analysis of student data and just reporting on that student data for the purposes of understanding how learning happens, and also just for the purpose of optimizing learning. And this diagram gives more of just a clear picture view of how the learning analytics process works, right? We have this learning management systems or learning platforms that generate data about students, and we collect that data. And what we do with that data, we analyze that data and we present that data in a form of a dashboard. So the problems that we work on in the center, around learning analytics mostly falls under the 4 categories of learning analytics. So we have the descriptive analytics, we have diagnostic, we have predictive, and then we have prescriptive, right? And most of the problems that we work on mostly falls under the first 2, descriptive and diagnostic. So descriptive analytics is basically us understanding what happened, in the historical data, us trying to understand what happened, and diagnostic is just us understanding why did this happen, and predictive analytics is just us trying to focus some of these possibilities. And once we get to the prescriptive, it's just us now making recommendations based on all the stuff that we did. So some examples of the 4 categories of learning analytics would include, like under descriptive, we have student feedback, right, which is gathered from surveys, right? So basically that's data that describes a student's life cycle. We have enrollments, study support, exams, and so forth. And diagnostic analytics is, you could say it's more of an advanced version of descriptive analytics, where we get more in-depth, we get more deep into our data. We apply data mining techniques to further understand our data and to further just understand why we got certain insights from the descriptive. And that analysis can help us find key performance indicators and matrices to help us raise student engagement. And under predictive analytics, we have things like predicting dropout rates and identifying at-risk students. And particularly just to speak more on identifying at-risk students, it's actually a research that I'm engaging on how we can actually incorporate probabilistic machine learning on identifying at-risk students, because identifying if a student is at risk or not it's a very touchy thing. And when you build machine learning models, you don't want to have a model that just tells you a student's at risk of failing or a student is not at risk of failing. And sometimes they can lower the student's expectations. So if we use this probabilistic machine learning, we can actually predict if a student will be at risk or not. And we can also tell the student how confident we are if the student is going to be at risk or not. And that's just one way of tackling identification of at-risk students. And then we have prescriptive, which is basically just something that comes after predictive modeling, whereby you want to start making recommendations and so forth. So the learning analytics solutions, right, that the areas of education that's addressed by learning analytics are mostly retention, student success, improvement of learning design, courses, and teaching practices. And just to speak more, improvement of learning design, this is things that we see in surveys that we get, like surveys that evaluate modules, where students give feedback of what they think about the module. So we can use this to actually improve learning design and causes and practice. And we can also provide personalized student support. So I'll just hand over to my supervisor to just walk you through how we develop some of these solutions.
Thank you, Eli. I think you would agree with me that at the times that we're in, where a lot of the stuff that we've been doing practically in the lecture halls and classrooms has really been challenged over the past 2 years. And this one area has really been quite useful in understanding and in answering some of the questions that remain quite unanswered, that those who teach are quite worried if they have that high level of uncertainty in terms of who's showing up for class, who's engaged. And attendance itself was quite a critical question, which has really gone from simple as pitching up for class to being a very complex matter that I may not pitch for a class, but I may actually go and watch the recording of the class, or I may go and complete tasks on our LMS, learning management systems and so on, and still be able to be updated with the work. So therefore, there are quite a number of questions that then come as a result of that, particularly in the context that we find ourselves, where learning at home may not necessarily be the best thing to do in many of our students. So just to give sort of a context in this, and then move from there and look at the architecture then that we built, just really trying to emphasize this notion of serverless. There's 3 of us here in this team, and that's one reason why one wants to go more like serverless kind of work, partly because we do not have too many engineers to help us build some of these things, and so we heavily rely on making sure that the resources are being managed by somebody else, and we can focus much more on the business logic and also on developing the actual code. And so that's mainly what we sort of do. So we taking one use case of, for example, in attendance in a session like this where we're giving classes. And therefore, we look at how the sort of entire pipeline on how that data would flow into the AWS, and how we configure that to be in serverless mode. And both the focus would be on the Django app, which ingests the data, and then also on the visualization side, which is the R. So we use those two programming languages, Python and R. So my colleague will get a little bit deeper in terms of the serverless application that we have that we developed in Django just as a use case for data collection. So we have a number of data sources. For example, the data that is generated through class attendance, data that is generated through submissions, generated through LMS systems. We collecting the student engagement on LMS all the time. So we're able to sort of track all that data that sits in our student performance kind of data as well. So, and the survey. So we do try to integrate all that, but we would sort of focus, for the purpose of this presentation today, focus much more on one. But I will touch on how others sort of get into that architecture. Okay, so once that data is being collected, of course, that sits in some storage, and S3 becomes one of the important data storage that you can use in AWS. And from our RDS, and we have one relational database there, that data sits in there as well. So once that data has gone in, so this is the data of attendance, right? So that is generated. These are CSV files that are dumped into S3 bucket and then into the RDS. So what then happens is that we need to pick that data. So this has a potential of also becoming almost like an event-driven kind of solution. Once the data has been dumped on, then you can put an event listener there that listens to anything that happens, and then you could even put lambdas to fire up and do certain jobs. But in this case, we are actually doing much more of an serverless ETL pipeline, and I think AWS then provides us with this So partly I will talk to how we use these resources, mainly for people who may have not used them, as I've seen in other sessions that we've had through the summer school, where the speakers have shared on how you could create some of the free accounts on AWS. Of course, that has limits, but at least it does give some starting point. So what happened is that we've got Glue in AWS. So what Glue does, it helps us with data catalog. So it catalogs our data by creating this metadata that becomes our tables. And what's nice about it is that your data can actually sit in multiple sources, and then you can almost like glue it in, and then have these metadata tables that you have, which you can then start to do much more of analysis. From there, you can connect it to Athena and end up even writing SQL scripts that actually query even a S3 bucket for that matter. But that's not really the focus of today. But I was just sort of touch on how Glue can be used with Athena at the same time. So, and then from there we have a crawler. How does this catalog happen? We have a crawler, and this crawler. What it does, it's that it automates, automatically finds the schema of your data, and then it picks that up, and then it creates a table for you, which these are the catalog data that you have, the metadata that you have. The nice thing about this is completely serverless. So and you would not pay for idling resources. You only pay for what you use. And therefore, one of the key issues then is that that speaks directly to the ETL process. It helps you to also run jobs, and you can pick jobs which these jobs actually use these number of tables or metadata that you've got in your catalog. It pulls those into your jobs, and you can in fact schedule some of the jobs and run them at a particular time, or you can put an event that once something happens and then fire this job and so on. And what's nice about it is almost gives you this boilerplates in PySpark, and that you are able to do all your ETL from there, and you just edit the script, and you can in fact run it even locally and then just test it there. And then once done, you can then push it to AWS. So that's the beauty of that kind of work. And then it then enables you at the same time to transport data in a way, if I were to use that, and you can move it from any source to another. Once that is the ETL process is completed, you can just simply take that data and put it in another RDS, or put it in something like Redshift for analytics purposes, or whatever data storage you want to use. So that would be our ETL process. And then we I don't know if I can minimize this thing here. The last bit here is I've used R for quite a long time, and mainly for the research work, and then obviously later on receiving much popularity around data science work, and I think much resources have been developed as a language to do a lot of advancing work, particularly for me around wrangling, and I think there's been developments around modeling as well that is quite more closely to more machine learning than just statistical models. So one of the challenges is always that I think R has always faced was scalability was also one of the major issues, and R has this shiny package that helps you to build these webs. This web apps, and that's what we use for visualization purposes. And what I'm trying to do here, or what we're trying to do with my colleague here, just to describe the process, even though we will not completely do that. Just checking my time here. We'll not be able to completely do that. We'll give some ideas and touching on this, how one thinks about making this completely serverless. So, but I think one assumption that I'm going to make is that you have a little bit of understanding on how Docker works, because it works with these images and so on. So instead of using Vim, you use Docker, and that's something maybe if you're not familiar with, you may want to look at and see how it does the complete isolation of the application that you're running. It's almost like baked into one one container that instance of that image, which is the container. When it runs, then you have what you want to see, which in this case is our dashboards. So what we then do, obviously, we build these containers locally, images locally, and then we push them to ECR, which is this part here, right at the end. So we push them to ECR. Elastic Container Registry, and think of that as like something like what is that again? Docker Hub. Yes, think of that as a Docker Hub, but this is in the AWS space. So you have that as a registry. That's where your image sits, which is almost the entire application you have. But you just need to configure your network well that it can still speak to your other resources like your RDS services that you have. So that's where you start. I'm just now speaking logically how we would go about that. And then you need to create a cluster, ECS, Container Elastic Service, which to do that, for you to use Elastic Container Service, you need to create a cluster. And again, maybe some of you who are maybe not familiar with this may think you're going to pay for the cluster, but again, this is where you only pay for what you use. So you're not paying to create that cluster. So only when the container is actually running. So, and then you put in a definition, which is like just providing resources to your image on how much resources it's going to use, and you set that up, and you have that definition. And in order to fire up these images to get your instances, which are containers, you'll have to create a service, which is this part here. You'll have to create your services, and these services will run these containers. Just to touch on one security matter, you may want to separate where you're running your containers, that you make sure that they run in a private subnet, your private VPC, so that you're not running them in public. And therefore, you can configure your network there by either putting your splitting that into two, public and private, and you put your application load balancer there just to manage your traffic, and then from there your web will be running. Just make sure that you configure the RDS services to be the same as the container. So this is how we're thinking of our architecture and how we have up to this far. So essentially, some of those others that I talk about, all they do is just to give us more data sources in the beginning, and we push those into Glue again, and we are good to go. So I'm gonna again let my colleagues just to get into the details of some of the work that we have done.
Oh, thank you so much, Dr. Musia. I think my colleague has shared our architecture, which is quite extensive and seamless, if I do say so myself. We want to dig deeper into the Django application, or the first part of our architecture. This involves the ingestion part, where we try and get our data into this whole pipeline that we use. So allow me to please share this part of the screen. Let me get that. Okay. So remember, Django is a Python framework, right? And I need to really explain why we chose Django in the first place. Django is fairly easy to use, and it's quick. You can really get from the ideation phase to launch in almost no time. And what's also nice about it is that it has well-defined design patterns, to develop these web development web apps that we use to ingest our data. And of course, it helps us then to focus on creating our app or our business logic, rather than reinventing the wheel or coming up with something brand new from the ground up. And last but not least, it's free and open source. So why are you still deciding on other things? So let's look into the Django design pattern itself. Django works on something called MVT, the model view template design pattern, rather than the MVC, known as the model view controller design pattern. So what makes this different is that, so let's go to the model first. The model, naturally speaking, is the part that handles our database. So this is where all the data would sit, right? And then the view that we see here is where our business logic. This is where the hard coding goes in and really where we have the functionality coded in. And when we look at our template, you could think of this part as our user interface, the actual web app that the user would be able to see. So in this demo here, we see a user querying the Django controller, because remember, it works on MVT instead of MVC. So the user would query the Django controller for a resource, and Django would ask the URL, like, look, man, is this resource available? Can you try and get this such and such for me? And the URL will be like, okay, let me check out with the view. And the view will be like, yeah, it's available, because remember, the view is where all the logical code is. And the view would query with the model and see if we need to get some data, and then render that to the template and respond back to the user and say, hey, I found what you're looking for. So that's fairly how the Django model view template works. So now that we have a maybe brief understanding about how Django works, let's look at how this deployment works. So please let me know if we can see my full screen. Can we see my full screen?
Yes,
yes, I can see it.
Thank you so much. So I'm really not going to go into coding that much, but I want just to just see the folder structure that I've been talking about, so that you see that the MVT design pattern is truly evident here in Django. So our first file being URLs file, which really routes all the requests we make, and this is then routed to what? This is routed to a view where all our logic would be. So when we go to views.py, we'd see our logic. And this is really just printing a simple HTTP response. But you can see the URL part and the views part. Of course, the model part really has to do with your database, and then your template, remember, is where you render some nice UI that the user can experience. So with that out of the way, let's get into deployment, because the focus for today is serverless, because we really don't have time to be managing our own servers in the time that we live in. So we use a tool called Zappa, which is also open source. Thank God for that. And so I have a Zappa config file in front of me. So we don't need to know everything that's going on here, but I want to point out a few important parts of it. We just have a section that has to do with our credentials, some configs, project profile and stuff like that. And then these are really just, user-based configurations. But the important part is really the excludes part. Why do I say this is important? Because this config file contains all of our, not all, but it contains sensitive data. So you wouldn't want this to be pushed to the container. Even though the container is private, but if someone gets to the container, that means they'll be able to get to the secrets, which we don't want that to happen. So that's why you would add it to your exclude section. Moving on from the exclude section, you'd get your environment variables, which are then, your secrets that I was still referring to. So don't try and memorize all the options and parameters in our Zappa config file. The nice thing you need to memorize is just two simple commands. And really, when you're done with your app, you really just want to deploy it using Zappa deploy, and the name of the stage, which would be dev or staging or production, and you just say dev, press enter, and it'll do its thing. And the whole serverless deployment is abstracted in this beautiful package called Zappa. And if you make a change, you could just change that to Zappa, update dev, press enter, and your change will be live and visible to the users again. So that's a little bit how you could deploy a Django app serverlessly. So let me take you back to a sample application that you could use to ingest data. So my colleague spoke about CSV files. So you would upload a CSV file, you would fill in some parameters like school, department name, program name, module code. And when you click submit, this will obviously be pushed to the CSV, to the S3 bucket and nicely into a database. So ingestion is done beautifully in an easy to understand user interface. And from there, we would get to our visualization phase. Thank you. I'll hand over to my colleague Eli.
Okay, thank you, Melvin. Okay, so I'm just going to explain the process, like what happens after we now have created the system that collects data for us and people use that system to upload data, or people use that tool to upload data. What happens afterwards? So we basically use R. So R is basically just a data science programming language that we use, to generate some insights or to analyze our data. And Shiny is basically like a library, our library that we use to create web applications for users. There will be our like management, management in education, educators, to create applications that educators can see and interact with. So we have our data collection process, right, which my colleagues just described and went through just now. And then after the data collection process, we now have the analysis process part. And then after the analysis, we now have a part where we create our dashboard. So just to give an overview of how the Shiny architecture more or less works. So we have our user interface and then we have our server. So our user interface is basically what the user will see, and the server is basically just what happens at the back. So the user will maybe give an input in the user interface, and the input will be processed by the server and will be rendered back to the user, and the user will be able to see what happens. And this will be made more clear after you see how we design some of our dashboards. So this dashboard particularly is based on simulated data, and these are some of the dashboards that we develop. And in particular, this is a dashboard that's based on student attendance analytics. And as we could see here, using R Shiny, we can create highly interactive dashboards. Like you could see here, as my colleague explained previously, we have this form where maybe an educator or someone in management will fill. You pass in a module name, you pass in the department and so on. And the same thing happens in Shiny. So basically, you're just going to fill in certain options and it's going to give you desired results. So it will give you results. If you are an educator lecturing a specific module, it's going to give you results on that module. And we cannot just do it on a module level. We can do it on an institutional level and so on. So as you could see here, we have some insights on average attendance by year of study. And this is just us having some line plot that just helps us track, our attendance, how attendance is over time, and so forth. And moving on, we can also track things like how does attendance vary, in weeks. We can check the attendance of the previous week, we can check the attendance of the current week, and we can check how it increased and how it decreased, and just to give insights and also try to find out why. And basically, this process I'm defining now is just basically the descriptive process where we just trying to see what's happening, and after this, of course, then comes the diagnostic process whereby we see, okay, there was like a 200% decrease in attendance. What can we do? We can try to do more in-depth analysis and try to understand why was there like a 200% decrease in attendance and so on. And some of these stuff are just KPIs, are just key performance indicators that we can just monitor over time and see how it compares to some of the analysis that we have in the dashboard. And here we have like a module section that we created. So this module section is like a section that's specifically directed to an educator. So an educator would use this section to see which weekdays, on which weekdays are my students most likely to attend my class. And that provides you to tell you, most of your students attend classes on Thursday. So what can the educator do with that information? And we also have things like that checks the average class attendance, that checks the average duration, how long do students actually attend your class. And we can also compare that with the student statistics, where we gather the students' attendance over time and see on average how long the student attends the class and so forth. So this is just a subset of what our dashboard provides. And then, of course, we have multiple data sources, because in student data, you can divide student data according to student learning behavior, student performance, and student demographics. And then we have the student learning behavior, which is mostly captured in our learning management systems, right? And what we can do with that, we can actually extract data from our learning management systems and create dashboard that will help us understand student behavior better and understand how do students engage with our online resources and how do they engage with some of the platforms that the school uses, to distribute resources and so on. So here in particular, we simulated data based on student engagement on online platforms, just to demonstrate some of the dashboards that we create. And this one in particular is based on engagement. So we have student engagement. And one thing that we particularly did here, we saw that, what if we can somehow use an unsupervised machine learning method, whereby we use k-means clustering to cluster students, and see students that have similar learning behavior and devise strategies that work for each group. And this is just us applying K-means clustering to see what meaningful groups do we have, and how students engage in each group and so forth. And basically this just gives us a visual representation of how many students are in each group and so forth. And I'll just give over to my colleague to just explain now, to just further explain.
Thank you, Eli. I see we're not doing that well with time, so I'll try to be fast as best as I can. So just to really show some of the work that we have, where we're wrapping our minds around issues of learning and how to deploy some of these as data science skills. This is one way we are thinking about it in the Center for Teaching and Learning. So this is actually linked to student academic support that either have supplementary instruction support or they have tutorship programs that they run and so on and so forth. So there's a lot of other activities that gets fired as a result of these evidence that we have before us. So this is in particular also one of the responsibilities to actually do staff capacity development, and therefore we try and understand from LMS systems on which learning designs are more engaged for students. That's one particular issue, and therefore once we pick a particular design, then that informs our capacity development through tracking this whole process and using that data to inform those kind of capacity development activities. And this is one of those that has a couple of activities that are done online, and we look at how which resources attract students and which learning designs, which is essentially how decisions that are made by an academic staff to set up their course online, and how does that lead to more engaged. And actually we do even further statistical tests on whether which learning designs is more providing more significant results as compared to the others. But even though this is more work that looks into more of a historical data, and to some extent then can inform the next round of capacity development. So that's essentially how we do that. And we also look at sort of time spent in completing. So one important aspect here, particularly that we're online, is that you want to understand fairly the dosage of learning that happens. So you want to know how much learning time that the students spend. And again, we are hoping as we're growing, and I must say this is still in an infancy stage, right? So our project are sort of being started as most of it from last year's work, and we're trying to push that as much as we can, and we are hoping that we can actually start to do more interesting and recommend kind of systems that we can provide, as we had from the previous presenter, on how students can organize their lives and their lifestyle in a particular way, as a way that can enhance their performance. So as part of that, we do have web scraping that looks at, as part of understanding learning designs, we have a web scraping that happens also, that just picks in the learning design process what are the activities that academic staff puts on the LMS, and this would be one of those simulated data of those kinds of things, as one would understand that could be quite a sensitive data and it belongs to the university. So I guess that's really the point that we are sort of trying to make today. Our ambition was really to give you a sense of what we have done and our thinking and so on. And we were hoping that we could actually live demo quickly one of them, but I think we may not have time as we have passed away the time that was allocated for us. Chairperson, we want to pause here and perhaps pick up any questions if there are any. Thank you.
Okay, thank you so much, Dr. Musia and the rest of the team. Ms. Dina has a question. I don't know if she minds unmuting herself and ask the question.
Thank you, Hannah. And thank you very much for the good presentation. I just wanted to understand, when using R-Shiny, what database do you use on the back end?
Okay, we're using relational database, and in this case, we're actually just using a Postgres.
Dr. Musia, sorry for interrupting. I think it's still fine. You could perhaps demo.
Okay, I'm gonna ask my colleague to just jump in and show you how easy it is just to start a Shiny app. You'll do a simple one, maybe for the colleagues who haven't used Shiny or R for this kind of interactive visualizations. Eli, can you just take about a few minutes just to kick in this?
Okay.
Yeah. Okay.
So assuming you have R and R Studio installed and the library R Shiny installed, right? So you would open your R. Just let me know if you can see this.
Yes, we can see it.
Yes. So this is more or less how your R would look like, right? Of course, you can customize how you want your IDE to more or less look like. So one thing that you would do is that you would start a project, right? So you go to File and let's see, New Project, and you start a new project and you create a new directory, right? So new directory, and then you can just click New, you can just say New Project, right? And then you can just name the project, right? So you can just name it Learning Analytics, what is it, Dashboard, just for an example, and you can browse where you want this to be. And let's say we want to put it by documents, right? Or we can just put it, let's see, let me just cancel this. Let's see, browse. Let's see. Very good. I don't know. Excuse me, this is my colleague's, what's his laptop? So TS Africa. So where is the folder DS Africa?
Just save it.
Okay, let me try that.
I think it's this one, right?
There we go. Yeah.
So open, and we can create the project here. And immediately after creating the project, we'll obviously move to the project file. So as I discussed, there's like two ways in which you can actually create your Shiny application, right? And you can create it just creating an app file, right? So you can create an app file. So let's say we want to save this, right? And if you want R to recognize something as a Shiny application, you have to name it appropriately. So we're going to name this app, and we're going to save, right? And then that's that. And then we can write some code here. We can just import the library, and then we can say this is Shiny, and so forth. And then we can save this. And another way to create a Shiny application would be to just create, I wouldn't advise using the app.r method, because you would just have one file that has just a lot of code, especially when you scale in your application, you're trying to add certain things that you want to look at. It can get a bit messy. So I would advise having a separate file that looks at the UI part and looks at the server part. So I'm just going to save this. Let's see. Let me just create a new file. So Control Shift N, and then save. So I'm going to save this as UI, and then save this, and then I'm going to Control Shift N, and then save this as server, and just make sure the names are written correctly. Yeah. So now you can see after saving this as UI and server, basically R gives us an option that says run application, right? So we have that option. So this is just one way in which you could create an R Shiny application, or just create files that contains your R Shiny application. And then you can start by now, you can now start by importing your libraries, right? So what libraries are you going to use? Let's say, of course, you have to import Shiny, and you can import another library. By the way, this is different from Python. I know with Python, you want to say import library as, but with R, you just say library, and inside the library function, you put the library name that you want to use. And there's multiple versions of Shiny. There's Shiny Dashboard. And then again, this is my colleague's laptop, so I see it doesn't have Shiny Dashboard. So I'm just gonna stick with using Shiny, right? So just to demo more or less how a Shiny app would look like, right? Let me just say new project. Let me just start on a project to make things easier. See new directory, and then I can just say Shiny web application. And I can just name it DSA LA, and then I can just say create project. And basically what R does, R will basically start this with an app that's already made, right? So I'm just going to more or less explain the logic that I spoke about, right? The UI and server logic. Of course, this is just using one app. But then since I explained the using UI and server separately, so we will just do that. So we're going to create the UI and server separately. So Control-Shift-N, and then Control-Save, and then I'm going to save this as UI. And then this is basically, the UI is basically what the user sees, and then Control-Shift-N, and I'm going to save this as server. Okay. And now what we can do is that in this application, right, we have our Fluid page, right? Our Fluid page is just like your home page, basically what you see on the browser, you could say that, right? And in our Fluid page, we have a title, right? And yet Old Faithful, yeah? And inside it, we can have like a sidebar, and in the sidebar, we can have a sidebar panel where we put certain things that we want the user to interact with. Like this one, we want the user to give inputs using a slider, right? And so forth. And then we want to output it, or we want to output something, you know, when the user gives input. But then the thing is, this output has to be somehow processed, you know, and rendered from the server end. So we're going to tell the server that when the user gives an input like this plot, right, take that input and then render some plot here. In this case, the plot is a histogram, right? So I'm just going to copy and paste this and just show you how you can do it in the UI manner. So I'm just going to copy this. Okay, yeah. I'm going to copy this, and then I'm going to paste it in the UI. And paste that, and then I'm going to save. And you don't, when you create an application in the UI, you don't have to necessarily specify UI is equal to that. And in Shiny, as compared to other languages, don't use equal. Rather, they use what's this sort of arrow to assign objects, right? So basically, that's what it's doing. And for the server part, so all we need to do is just come here and copy and paste our server code, right? And hopefully this runs. And we paste our server code, and I'm going to run application now, and hopefully this runs. Yep, and basically, this is more or less how the application would look like. But of course, you can build more advanced applications. And as you can see, as the user gives some input, that input basically gets rendered by the server and gets somehow processed, and then you get the output back in the user interface. So basically, that's more or less how Shiny works. So hopefully next time we can actually give a proper walkthrough on how you can actually create a proper interactive Shiny application, how you can add elements and so forth. But for the sake of this presentation, I think we'll just stop here. And is there any questions?
Thank you so much. There aren't any questions in the chat so far. I don't know if other people would perhaps pick up their hands and want to ask the questions. Oh, Mr. Martin, could you please unmute yourself and ask your question? Okay, the question that was asked is Shiny for data visualization?
You can use it for, the main purpose of Shiny is for data visualization, but you could use it for multiple things. You can also use it for machine learning, you know, creating machine learning applications, just as we showed, whereby we just created a web application that has a K-means model running backend. So you can use it for multiple things, actually.
If I were to come in, Shiny is almost like abstracting away the CSS, JavaScript work, and so on. It's just an R framework that enables you to almost just sort of focus on the actual logic of your application and not worry a lot more about that kind of work. And I think when it started, it was quite useful for people who came from the background, which wasn't really where they came from, web development side, but it was quite useful. And I think it's sort of growing quite rapidly. And we could share resource. I think Hartley Wickham, the RStudio guy, has got a nice book that even that's open source that we could share a link to that book if necessary.
Okay, I think that would be really helpful, Doc.
Okay, thanks.
I'm not sure if, oh yes, another question is from, I don't know, Mr. John, could you please unmute yourself if you, and ask your question?
Good morning. Thank you for the presentation. Between R-Shiny and Django, which one is best for database building?
Go. Okay.
Yeah, so look, in terms of database building, you want to be using Django simply because it specializes for that. It has a design pattern built in already. If you're going to be using R, it's possible, but you're going to have to create your own logic and classes yourself, really. So it's possible in R, but it's very, very challenging and difficult to do. So choose Django because it's built for its purpose for that. So yeah. It's not about what tool what you're using. It's mostly based on use case. So your use case is you want to build a database, you want to have a database in your backend, go with Django because it specializes. It's purposed for that. Hopefully that answers your question.
Yeah, thank you.
I don't see any other questions. So I would like to thank Dr. Musia, Mr. Melvin, and Mr. Eli for such a wonderful presentation. It was very informative. And once again, thank you so much. I don't know if we would just please give them a round of applause for that very, very informative presentation.
Thank you. Thank you very much.
Thank you.
Thank you. And the next presenter is Mr. Vernon Clark, who will be presenting on severity estimation of potholes in imagery using convolutional neural networks.
Thank you very much, Anna. Can I start? Okay, good morning, everyone. Hannah, can you please confirm if you're able to hear me clearly? I'm using a bad mic.
You are audible and your screen is visible.
Okay, thank you very much. Today I'd like to speak about severity estimation of potholes in imagery using convolutional neural networks. So let me introduce the topic. So roads and highways are free to use to all, and as such have attracted traffic of varying shapes and sizes. So you have your pedestrians, you have cars, you have trucks which carry heavy loads, and you even have bicycles and scooters. So potholes are holes in the road formed when water enters into cracks in the road surface and expands. So you have your truck passing over a particular section of road which might not be paved correctly or something. So because of the load in the truck, passing over that several times starts to form cracks. But now these aren't the cause of the potholes. What now happens is when you have rainy weather or your floods or pipes burst and things, the water enters into these cracks. And then the sun shines after the rain, of course. So the sun comes out and then it expands this water that's nested inside the cracks in the road. And then this then causes the tar on the surface of the road to become very brittle. So now when your truck passes over again, instead of just making the crack now, it basically is digging a hole. So that's how the pothole is formed. In Kimberley, much resources and attention go into the fixing of potholes, but somehow it's not accurately done. But that's a presentation for another day. So the problem statement. So traditional pothole remediation techniques are time-consuming and error-prone. So it would traditionally consist of locating the pothole. Normally they make a nice white mark with spray paint around where the pothole is. Then you would have to come back and clean the pothole. So this would consist of either turning the shape into a square so that you can nicely fill it, and then sweeping inside, and then some even make it a bit deeper, so a certain fixed depth. And then you can come back and actually fix the pothole. So you would come and put your tar in, and then perhaps use a jackhammer to just make sure the tar is nice and firm. But then this presents a number of concerns, like resource deployment. How do you gauge which potholes deserve more attention and which sections in Kimberley potholes deserve more attention? So this is the question that drives this research. So the problem statement continued. The traditional pothole remediation process presents a number of concerns, but those covered in this research article are traffic volumes. How can you take traffic volumes into account as well when fixing potholes? Pothole locations, and then pothole dimensions. How can you take pothole dimensions into account as well when fixing potholes? So the traditional remediation process disregards any information about traffic, like for example, which roads are busier. And in cases where traffic volumes are considered, the severity of the pothole is not taken into account. So just because it is a busy section of the road, if the pothole is only 0.5 millimeters deep, does it then mean that it needs to be fixed first, as opposed to fixing one that's on a less busy section of the road, but is 10 millimeters deep, which could cause serious damage to your vehicle's tires, as well as your steering, which can then in future cause accidents. But it would never be tied to the pothole because it's subtle, you know, it's on the tires and the steering, which is really tied to being caused by the pothole.
Sorry,
So
Vernon.
Yeah, awesome.
I don't know if you have started moving your slides or not, because you're still on the very first slide.
I'm still on the first one. It shows number 4 on this side. I think it's my network. Eh? Let me just stop sharing quickly. Just hold up. Okay. Can you see it now? Can you see movement?
Yes, we can.
Okay, so the first one would be this one, right? So I should start from here.
Yes, it's
okay, is it still moving, Anna? Please confirm.
Yes, it is.
Okay, I'll just continue then from here. So can a process be developed that allows for automation of the above mentioned process? And how can the works of previous researchers be reused? Because we would like to reuse previous works and not start afresh. So just a review of some literature. From a review of literature, it can be seen that a number of interesting approaches have been developed. So I'm just mentioning some of the authors here. Among these interesting approaches have been your sensor-based, some where you attach a microcontroller to the inside of the vehicle and then monitor the fluctuations in the acceleration of the vehicle. So this would be that when the vehicle slows down, for example, and then also using the change in the springs of the vehicle, the shock absorbers of the vehicle to also detect when a pothole is encountered. So the vehicle, as previously mentioned, would be driving normally, for example, 30 minutes, and then all of a sudden it would stop and then have to go through some pothole, and then the suspension will also go through some stress. Through your model-based approaches, not your traditional machine learning model-based, but more of your physics, from your physics domain-based, where they model the interaction with a pothole. So you have a model for when the front tires encounter the pothole, and then the change in the suspension. And then when all four tires are inside the pothole, measuring the change in suspension as well. So then the researchers would use this to try and estimate how deep the pothole is. These approaches have achieved relatively well success rates. But in this article, we'd like to focus more on the machine learning-based approach, because the physics model-based approach, it relies heavily on manual feature engineering. But from a study of deep learning, we know that deep learning exhibits the automated feature engineering. So you would have basically a black box, and then inside the features are engineered for us. We just give the inputs and the outputs, or the inputs and what outputs we expect. So traditional methods have relied on smartphone sensor technology or vehicle-mounted sensors, as previously mentioned, with the microcontroller inside the vehicle, or machine learning to detect road damage. Now, the previous machine learning approaches that are out there detect the damage. So this is different from the severity estimation. This is just the detection of it. So given a picture, is there a pothole in this picture? Which does kind of help us fix the roads if you're using an automated fixer that needs to identify where a pothole is and then fix it. But it doesn't really gauge the severity of the potholes, which we'd like to use to inform which potholes should get fixed first. So object detection. So object detection algorithms make use of neural networks to identify patches of an image containing an object of interest. As mentioned before, you could have your pothole in an image, and then you'd like it to identify that not only there is a pothole in this image, but where exactly is this pothole in the image. An object detection algorithm takes as input an n by n image and produces a bounding box or bounding box predictions where the pothole is in the image, just as square coordinates. So the bounding boxes are the model's estimate of where the objects are located in an image. Object detectors have been modified to produce estimates of bounding boxes and image class in a single pass. These refer to your more recent object detectors, which don't just do the detection, they can do a detection and a classification. So the object of interest in this case is the pothole contained in an image. So convolutional neural networks, the CNNs in the title, make use of several processing layers before feeding to a fully connected neural network for your output classification. So convolutional neural networks are able to learn low-dimensional representation from high-dimensional data. And also in cases where we don't know what our features are, or the methods for encoding or creating these features ourselves are just infeasible, we would like them to be learned automatically. Like I do not know how to program a Python script, for example, that can locate a pothole in an image using rule-based methods, for example. Like if it looks like this, do this, if this, then that. So we use CNNs. In this study, pre-trained convolutional neural networks are used as a baseline with few tweaks to modify task for the regression task. So essentially, our task in this research article is an image regression task. So we are assigning a real value to an image. So the proposed method, yes, how are we doing this? Or how do we propose this be done? The proposed method for severity estimation consists of two independent stages, namely a feature extraction stage in which an object detector is used to extract the path of the patch that contains a pothole. The extracted region is fed to a convolutional neural network for estimation of pothole depth. So that's where the heavy lifting really comes in. is at the second stage, where the estimation from the title comes in is at the second stage. So the strength and generalizability of a model is determined largely by the design expressibility of the state representation. So when you think states, you might be thinking reinforcement learning. But what we mean in this case is that the state representation for our model or agent would be this image, and it could potentially be containing a pothole. But if you have an image with a pothole inside, but it's got a car inside and it's got a flower and it's got a bag and it's got some shoes, you don't necessarily want your model to focus on these, because remember that the second part is a CNN. So our CNN does image regression. It doesn't need any of that other information except where the pothole is. So a model trained to classify images of apples and oranges will perform poorly at classifying cats from dogs. Yes, this is true, definitely, because it wasn't trained on images of cats and dogs, so we'd expect it to perform poorly. But is the cat and dog or the apples and oranges classifier totally useless when attempting to classify dogs and cats? Because it would consist of the same kind of stages, you know, like your edge detection and then eventually your classification layer. But the intermediate layers between input and output might be many of the same. So even the parameters might even look exactly the same. So this is where transfer learning comes in, and it will be discussed at a later stage, how we incorporate the transfer learning. The proposed method continued. The purpose of this paper is to develop a processing framework that is able to accept as input an image and output a depth estimate. So your image could potentially contain a pothole or not, and then at the output end, you get an estimate of how deep this pothole is. So this is achieved by means of two pre-trained networks glued together sequentially. So they are trained independently, and then we just accept the input from the output from the one as input to the next. So the first one is a fine-tuned faster RCNN with a ResNet 50 frame proposal network. And then the second part, so this first part extracts the patch of the image that potentially contains the pothole or not. And then it's fed to the second part that's modified for image regression. So it's a pre-trained deep convolutional neural net that's modified for image regression. They are famously used for classification and have performed very well in classification, but are rarely used for image regression. So let me look at data collection. So we have two separate networks, which would require two separate training stages. So each stage of the two-stage model is trained independently using two separate datasets. The object detection network is trained using a dataset of potholes annotated with their respective bounding boxes. So the input-output pairs that you are used to would be, the input would be the image, and then the output would be the bounding box coordinates. Okay, the dataset used to train the second part of the network is manually collected, and the first part is large enough to produce an accurate pothole detector, but it's not able to be used for classification or regression, as mentioned previously, because the ground truth is not classification or regression, it's a bounding box. Well, essentially it is a regression task because it's the bounding box coordinates, but in our case, we want the depth. So a second data set is collected for training of a depth estimator network. So these images of the data set used to fine tune the first part of the network, which is the object detector. And this is a snapshot of the data set that we manually collected to train the convolutional neural net. So we did look on the web. There is no data set previously that is of this form where you have the image and then the pothole dimensions. So we had to go out and collect this ourselves using a ruler and smartphone technology. So your smartphone would be used to capture the image itself, and then you can extract the location of the pothole from the image that you took. You just have to make sure that your data is connected and that you have your location enabled. So if you look carefully at the image over here, you can see that this hole is collected 4 times. And you might be asking yourself why. It's from 4 different angles, and I'll explain why we did this approach as opposed to using the image augmentation. So yes, it is the same image from 4 different angles. So you'd have far, medium, and then close, and then one that's from an angle, for example. Yes, and all measurements are in millimeters. I know it's not displayed on the screen. So the data set 2 that was collected, yes, we collected this manually. Among the tools used are a bicycle, just to get around, and then a square. So a square is just an L-shaped ruler that we use to get the length and the breadth of the hole. And then we had a smaller square for the depth of the hole. So among the things collected are image location, pothole depth, pothole breadth, and pothole width. So pothole depth is selected as the target, just because of the way it was distributed, which I will show in a bit as well. And then all these data samples were collected in and around of the Johannesburg CBD, which is quite busy. So you kind of have to wait for the ideal moment when traffic just simmers down a bit to start collecting this data. So yes, the distribution of pothole depth, as I explained why we chose this one. So when I did look at the density plot of this, or the histogram, it looks fairly normally distributed, which is good because it then shows us that the output variable is not some random occurring sequence of numbers. It actually follows some kind of distribution. So this would be a lot easier to learn than some random set of numbers, which will just make your model not converge onto a specific set of parameters. So testing for normality using your Wilcox test, for example, it is not normally distributed, but this could be on account of the sample size. So according to the center limit theorem, given a larger sample, we could indeed obtain a normal distribution. Maybe a sample that isn't just of the Joburg CBD, maybe the Cape Town CBD and then the Northern Cape CBD. So yes. These are just some summary statistics on the side here. Okay, so the data set pre-processing. So all images, because they were taken with the phone, tend to be large, like thousands by thousands of pixels. So these are first converted to 300 by 300, the curse of dimensionality, whereby you will need more examples if you want to generalize with higher dimensional input. So we had very few samples. So the smaller the better, but we also didn't want to make them too small that they become uninformative and are just blotches of pixels. For those familiar with the MNIST dataset, I mean, like that, for example. We don't just want blotches of pixels like all blocky and stuff, because then it might be hard to detect the pothole in the image. So picture location and date time is embedded within an image as mentioned previously, and these can easily be extracted. It's in an EXA format, which is similar to JSON or XML. So you can extract that and then just write short little query scripts that just extract the information that you want. So image augmentation is explicitly avoided. And here's why you might not want to augment these images. So take, for example, image augmentation that randomly stretches the image. If you do stretch the image, it then essentially becomes a different image. And then the dimensions that I did collect for it, which in this case are ground truth, are then not referring to the same image anymore. So that's why image augmentation was explicitly avoided. You might be able to get away with some random flips maybe, but we just decided to take pictures from different angles to counter or to combat this. Results are coming soon. So once the data set had been collected for both stages, it was an accurate model. Now, this is a nightmare, obtaining the accurate, unless you have years and years and years of experience with models. So this was problematic because the data for the depth estimator is super limited. And no matter how much hyperparameter tuning you can do, it might be the case that you just won't get an accurate model that learns. So manual exploration of these hyperparameters is time consuming and error prone. You could decide to start with 2 layers and then be like, no, what if I add a 3rd layer with 100 neurons? Or what if I add a 4th layer with 10 neurons? And this could go on and on and on and on. But at some point in the research, you want to put a stop and publish your results. So we had to find a different way. And the solutions to these was transfer learning and AutoML. So transfer learning, you pre-use you use or you reuse the pre-trained parameters from larger models. So these would be like your VGGs or your ResNets, for example, and then you apply them to your model. You define your architecture, you import those parameters, and you just modify the input and output layers to perform your specific task. Now, these models have been trained previously on large data sets of images, which aren't readily available to us as the public. So transfer learning is the lifesaver. It's a lifesaver when you want to build the deep learning models, but don't have the data source or the data set size needed. And then AutoML, this is another lifesaver. I would even say that it's more of a lifesaver than the transfer learning, because this one automatically tunes your model architecture. So the architecture tuning would be your neural architecture search, which was also done in this article. And then it also does, for example, your number of neurons. It can find, using your input data, your given loss function, and your output metric that you want, it can find the best architecture for your model, which does away with most of the hyperparameter tuning. And don't worry, data scientists, that doesn't mean that you'll be without a job. It just means that you'll be able to solve problems faster now. So the Roy extraction network was kept constant. Yes, we didn't want to modify this one at all. We just wanted to keep this one constant so that we can just focus on tuning the hyperparameters of one. Because having too many variables running about in your study will just make you lose your mind, because they'll just be all over the show. Yes, model training. So dataset 1 used to fine-tune faster RCNN with ResNet 50 FPN, frame proposal network. The Roy extraction network obtains an MAP of 23.3. This is not the best MAP out there. It's actually very bad. But for the purposes of the study and for the hyperparameter tuning and collecting more data, we just wanted to publish these results to show that this network does work. So dataset 2 used to train the depth estimator was the VGG16 and ResNet 50 were explored. So you give these as input to your AutoML and it automatically explores them for you, removing and adding layers as necessary. Are used as base models for the hyperparameter search, as mentioned. So yes, the results that I've mentioned previously, which we, from the get-go, since we see that the MAP is only 23.3, you might not be too optimistic about the results. And even from looking at the learning curves, you might think that this model could do a lot better. And you are right in both cases. It can do a lot better and you shouldn't be too optimistic with these. Oh, you should be optimistic about these results. And yes, you can do better than this. But what the learning curves do demonstrate, and it's not shown on the graph, is the downward trend of the loss over epoch. This is learning, ladies and gentlemen. This shows that the network was learning, it's able to learn, and it can indeed, given perhaps more data or your dropout layers or other accuracy improving techniques, given more of those, it can indeed produce a super accurate model. And also note that the network was only trained for 10 epochs. So this is by design, because at the time we were using Google Colab. So Google Colab does give you the option to use GPU accelerated environments. But when we do run these trainings, you don't want to sit there and watch it the whole time, like epoch 1 go by, epoch 2, epoch 3, until 1,000 epochs. So what we tried doing was training it for 100 epochs and then going on with our day, which is quite normal. So we'd like to do other tasks throughout the day, maybe compiling the document and such. Now what Google Colab does is then stops your environment from running. So to sum up, we were able to get away with 10 epochs, which was also a few hours of training, perhaps 5 or 6. So we were able to get away with 5 or 6 hours of continuous training. So solutions to this problem, it can be combated. You can use model checkpoints, or you can use warm starting, where you train for 10 and then you stop, you reset the Google environment, and then you train for another 10, but not from start. You use the previous parameters, you reload them into your network, and then you continue training. I'm sure you could get away with training for millions and millions of epochs after you take that approach. But this only became evident to us after the work was published. Yes, the moment everyone's been waiting for, the results. So these are the results on some test samples. So as input on your left side over here, you have your image that may or may not contain a pothole. And then on your output, you have the output from the model, which is we have the output from both parts, which is the bounding box showed in black as the black square, and then the green box shows the ground truth bounding box. Also, you have the actual prediction, which is labeled as actual. So it's actually 50 millimeters deep, and then our model predicted that it was 45 millimeters deep. Now, one thing to note here is that our model did obtain an MEP of 23.3. So the fact that it was able to identify a pothole in this image over here, which just looks to me like one big pothole, or this part over here looks like a pothole, and this part over here looks like a pothole, which is actually a good platform for me to highlight the weaknesses of the model. So yes, the 23.3 meant that no matter how accurate our second part of our model was, the fact that it didn't identify potholes as they were in the image all the time meant that the prediction might be being done on garbage, as illustrated in this image over here. So you have your input image on the left. So obviously this is the pothole over here, which you can see on the right-hand side in green. But then look at what our object detector picked up to be the pothole. So now when it does perform the regression task on this, it's just going to be a bunch of mumbo jumbo, and it's not actually going to be results that you can use. But to combat this, you could go back to your object detector, make it a lot more accurate. You can up that MEP to a definitely a higher score, perhaps in the 80s and the 90s. And then it might combat this problem over here. But what we wanted to illustrate is that severity estimation can be done from images. And we hope that future researchers might think of this as some of their research tasks or things, and maybe take the research even further. Yes, these are just a summary of the results. We trained for 10 epochs with a constant learning rate. Also, what became apparent afterwards is adaptive learning rates. And yes, that go up and down as your model trains. So the proposed model is tested on a 0.2 split. That means 80% of the 118 images are used for training, and then 20% of them are used for testing. And that's how we came up with the mean absolute error, as you see over here. So in the end, we ended up using the VGG6. We used the ResNet 50 one because it obtained the least error of all the models explored. Not shown on this in this table over here is also the VGG19 and the VGG16 is shown. VGG19 and VGG50. Yes, they aren't shown on this, but these are the two best results. So in conclusion, this paper has detected how recent advances in the field of computer vision can be used to extract data from imagery that can prove vital in the remediation of roadside damage. This paper has focused on how pothole depth can be estimated from an image of the pothole. The learning curves suggest that with more compute and larger training sets, the error can be further decreased. So some future research directions to include, to consider, we look at ensemble methods. So instead of having these two methods separate from one another, we could have one end-to-end model. This helps because the parameters of the model would now be shared as opposed to learning two separate sets of parameters. Also, some future research works could look at a pothole remediation application that allows users to submit these images to a centralized server or a centralized DB, for example. And then we could apply the processing techniques mentioned previously, like extracting the location and then the depth using our model. And we could then turn these into dashboards and reports that the decision makers can then know where and when to deploy resources effectively. Thank you very much for your time. Are there any comments or questions?
Thank you so much, Mr. Brennan. At the moment, I don't see any questions in the chat section. Perhaps people that do have questions can maybe raise their hands and decide to unmute themselves to ask questions. Could Mr. Herman please unmute himself and ask the question?
Hannah, you may be having issues with his mic, but I do see the question in the chat. So Harman, yes, now that you mentioned the modern network architectures, recently I've been reading up on few-shot learning and even in some cases zero-shot learning. So what few-shot learning would be tailor-made for learning from few examples. So this would be ideal in this case, but it will come in future works. And then your zero-shot learning, believe it or not, is able to learn from no examples at all. So I'll leave that to you to explore how exactly it does that. But yes, we definitely plan on looking into modern architectures. Okay, I see Martin has a question as well. Martin, if you would like to have the code, I could make it available. You're actually the first person that's asked for the code. I could make the code and the paper available for you. So Martin, if maybe you'd like to share your email address and stuff, I could forward you the code and the paper, as well as the data set. Sorry, and I see I have another question from Mr. Maxwell. Yes, they actually were, Maxwell. When you do say type of road, I'm assuming you mean highway and like less public ones with less traffic. So yes, they were. I don't know if it's just because it's in the Joburg CBD, but more often than not, you would find that the busy roads within the center of town had absolutely no potholes. And then so which didn't work for me because I needed potholes. I didn't need clean roads. So to find these pothole images, you have to basically go to the outskirts of town, which was made possible to my bike. Thank you, bike, for carrying me to the outskirts of town. But yes, in the Joburg environment, the roads in the center of town, no potholes, and then on the outskirts, as you're leaving town, many potholes. So I don't know if that answers your question.
Yes, it does. But I was just wondering, in terms of whether the model is the effectiveness of the model, whether it's more effective on roads, for example, that are smooth, or roads that are more gravel, or that have yeah. I don't know if I'm explaining it well, but yeah.
Yes, I understand, Martin. Well, to be honest, I didn't really check that aspect of the model, but you could make it more, if it's more effective on roads that have gravel, you could improve it by including smoother roads inside your data set. But then, as mentioned previously, the data set does consist of, these are normally your back roads that not many people would take. Number one, because this was easier to collect. I didn't have the risk of being bumped by traffic. And then number two, the CBD, as mentioned, doesn't have your potholes. So the outskirts roads, these are normally super gravelly, like very coarse. And then the CBD, which had no potholes, were normally your smooth roads. But I'm assuming other towns and other parts of towns, it might be different.
Okay, I think there aren't any further questions, Mr. Brennan.
Thank you
so
very much. Thank you. Thank you.
Thank you very much for that wonderful presentation. And I think maybe the code and the link to the paper can be shared to everyone, because I'm also interested in exploring the research that you did. And thank you so much once again. I would like the rest of the attendees to just show their appreciation through the chats.
Thank you very much, everyone, for your time.
Thank you so much for joining us. And the next session is going to be a keynote from Ms. Kathleen. I'm not sure if Ms. Kathleen is here or not, or if someone else is going to be standing in a place. Mr. Kara is Ms. Maureen.
Yes, Hannah, thank you very much for the great job you're doing moderating this session. If Catherine is not around, we can have the next presenter, and I can see Teju is on call, which is a great thing. So we can go into Teju's presentation. Is that okay with you? Yes, Teju, I see your video is already on. Great. So please go ahead and take it away. We're happy to have you. Then we will have Catherine if she comes in after that. Hi, Teju, please go ahead.
Okay, no worries. Good morning, everyone. I will just share my screen now. It's still loading. Okay, we're just gonna give it a few minutes to load. Yes. So good morning, everyone. Good day to you wherever you are. I wanted to start with a reminisce about my first Data Science Africa summer school and workshop in 2018. There I met many people who are my mentors today, who are very close friends, who I look up to. So thank you to the organizers, and thank you for inviting me to give a presentation today. It's a big honor of mine. I want to talk about one of our ongoing projects, which we titled Improving Online Learning Experience Through Accent Translation. It's a project done under ASSD Lagos. Before I start, a brief introduction about myself. I am Tejumade Afonja. I'm a computer science master student at Zaland University. I also work part-time as a research assistant at CISPA, where my research is focused on learning generative models for tabular data, mostly focused on small data regime. I volunteer my time a lot to different activities, but I co-founded ASF Lagos 3 years ago, where we offer free AI classes for 16 consecutive weeks. So far, we've held over 100 classes. We are completely run by technical volunteers who we are indebted to. I grew up in Nigeria, Ibadan to be precise, and then moved to Zabrücken 2 years ago. today's content would go as follows. I'll talk about the tension between accent and comprehensibility. I would talk about this, or is it what's exploring? Is this project worthy of exploration? Then I'll move into the South DB project, South Sea project, which we have multiple different different sub-projects under the project. Then we'll briefly talk about ethical implication we've been thinking about and the broader impacts we want to make. So the tension between accent and comprehensibility. Before I talk about that, I would motivate this problem a little. English is the most widely spoken language in the world, with over 1.132 million speakers, and more than half of those speakers are non-native. And English is also a dominant language on the internet. Nearly 54% of the content is in English. It's recognized in 59 countries, and 24 of which are African countries. So the question here is that, like, the 1.132 million speakers certainly do not speak the same way, which is good. It's expected because we all have different speaking style. So the accent of each individual person always reflects your individual background, and it encodes a lot of information. It's a distinctive way of pronouncing a language. It somehow sometimes define, it says a lot about your country, like where you are, your social class and whatnot. So it can be a source of connection, this feeling of familiarity, and it can also, unfortunately, be a source of disconnection. And the question here is that, because accent plays this major role, an important role in communication, it deserves some attention. And when a person speaks a second language, it's natural that they would speak that in their native language, in the rules of their native language. And in the same way, when a person is used to being spoken to in the rules of their native language, it's also the case that it's difficult to understand content in a foreign language. So there seems to be this tension between accent, the way we speak, and effective information exchange. Eventually, one might say you get used to an accent if you're in the same community. At some point, it might be difficult at first, but then you finally get a hang of it, hopefully. But it doesn't stop the fact that it's an old problem. It's somehow affects people in different ways, and we want to investigate that. We want to think a little bit more about how we can do something about that. So the main question here is that, how do you get used to accent that you seldom interact with? And this can just be the case with online learning. Online learning, you have a lot of information, tutorials flying up and down. You need to improve your skills. The world is growing at a significant pace that it's hard to keep up. So you just want to find the right information at the right time where you can quickly improve your skills. So what happens when you have all of this information displayed to you in an accent that you're not very familiar with? It just had so much more cognitive load on you, and it just makes it difficult to be able to access these relevant resources just because of this incomprehensibility. So this is the motivation to the problem, and now we're asking the question, but since this problem has been ongoing for so long, it's hard, everyone knows that it's hard, then is it worth exploring? For us to get some statistics around how people are thinking, so we started a survey which is still ongoing. So far, we have about 374 respondents from over 38 countries, and 26 of those are from African countries, which we hope that you can also participate in this survey if you use the link to your right. So the first question that we ask is that, do you think that accent of speakers have an influence on the understanding of listeners? And not surprisingly, everyone thinks yes. It's one of those things that you feel, but like it's hard, but then you move on. And but we wanted to understand specifically, yes, we all agree that it plays a role in the way you learn, but we want to know, does it affect your ability to learn? Now we are being specific, and we saw a different distribution here, right? Like now a lot of people think that accent plays a major role in learning, but they don't think it affects them. They don't think it affects their ability to learn. You might find it difficult to understand the lecture at some point, but you move on, you find another resources, or you slow it down for some time. You spend more time to understand it, but it's okay. You learn it anyway if you're determined. So, but it doesn't mean that it's not a significant problem or people don't care about it, but we are just resilient people. We move on, we find a way to get what we want. We wanted to even see, is it just the case with some countries and not the other, and the same trajectory, like we see the same distribution across countries, like most in general, most people do not think it affects their ability to learn, but they certainly think that it's a problem. And to even move further into the survey, for people who said it affects their learning, we asked them to give an example of what they mean, what that might be. And these are some of the responses we got, which we clustered or classified into like different subgroups. For example, this respondent here feels like they lose focus whenever they don't understand the accent of a speaker, which means that a lot of people lose concentration. And another respondent says that it takes them time to watch something. They have to rewatch it at a lesser speed that they would normally do that, and it means that people spend time. It increases their learning and assimilation rate. Another set of respondents feels like it's a barrier to their learning. Sometimes they because of an accent, they had to default from a math class. It affected them like long time ago. For the rest of the next 6 years of their life, they didn't know that this singular choice to leave a math class would have that much impact in their life. So it means that it's possible that accents can be a way for people to miss opportunities. So like having all of this information, we distilled it down to 3 different key points. Like communication should make learning easier naturally. It should strengthen the connection between a speaker and a listener. But it seems like there is a knowledge gap that exists between a learner and instructor because of this difference in accent. And it also seems like people spend longer time and exert more trying to understand and assimilate a video or a content rather than assimilate the information itself. And, sometimes it can be the case that people are not motivated to speak because they do not, or like they have a different accent. This social problem, part of the problem, social part of this problem. So now to answer our question, is this worth exploring? The answer to us is yes. So we decided to sit down to think more about how we can go about this project. So we started with a series of what if. What if we can create a tool or a software that can be used to translate an accent? What if there is some toggle on YouTube that can say, you can use it to select an accent that is much more familiar to you and get this, the content displayed to you in that accent that is familiar to you? Would that help? Would that solve any problem? Or would that be creating more problems in the future? It's just like brainstorming. We're asking questions. We're trying to come up with a solution or answer a plausible explanation. We also ask, okay, what if we can create a web platform that allows crowdsourcing of accent data? We certainly don't have that, not that we know of in Africa. We don't have a speech database that just focus on different accents of different African citizens or like people from Africa, so to say. Like you want to see if you can have like different people, like Yoruba speakers, Igbo, Efik, go to different African countries as well to have them speak in English in the way that it is unique to their country and to their region. So we also thought about like building like models whereby we can classify different accents. So coming to all of this, it gave us like 4 different sub-projects we are currently thinking about, right? So we're thinking about like a data set for African accents. We're thinking about some set of tools to visualize some embedding where we can see maybe clusters of different accents. We're thinking about how to classify accent. Maybe this can be useful for customer service, where you can reroute the call to some other service that is able to handle the accents in a way that you can better understand the customer. Then we're thinking about translate, like can we build a model that can be wrapped in an API that aids translation of accent? So today I'm just gonna like touch on like the progress we have so far, which is on the SalterDB and translate, a little bit on translate. So for the SalterDB, what we do was we created a web app to collect data. So far, we have over 2,000 audio samples distributed across different accents. Thank you so much to everyone who has contributed so far. And from there, we extracted these speeches from Nigerian accents because we wanted to publish the data set. So we have currently published 919 voices of a mixture of different accents: Yoruba, Igbo, Hausa, Efik, Ibibio, Igala, and Edo on Zenodo. And we also have some open source audio post-processing scripts that we use to clean this data, which you can use for your own projects as well. So I will go into some of the insight we have from our data. So we have about 52% of the Nigerian people who identify as Nigeria, who are from Nigeria. 52.7% of those are Yoruba. We have also looked at the data from the major and minor ethnic group perspective. In Nigeria, we have 3 major ethnic group, which is the Yoruba, Igbo, and Hausas. And our data covers about 65% of those. And we looked at the country of residence of the people who donated. We can see that a significant amount of them live in Nigeria and they stay in Nigeria. And so these are just to help us understand the kind of data that we've collected. And this data collection effort is still ongoing. You can use this link to access it, but we also have a public dashboard. If you just go to salterdb.web.app/analytics, you should be able to view in real time the distribution of the data that we have right now for the Nigerian accent that we have classified. So we have about 290 Hausa speakers who have donated to our platform. We want to push this number as high as we can. We want to have a database of African accents, speaking English, and use that data for research, for any other research purposes that can improve the way we learn, improve the way we access information, improve the way we do customer service. So, again, we published this data set on Zenodo, but some of the things that we did before we published the data set was we listened to all of this data. It was a tedious process, but it helped us understand the kind of data that we have. And we didn't think of any automatic way to make this process any faster, because this was the first iteration. There was a lot of learning back and forth, and so we had to listen to all of this audio to identify some of the things we need to clean. So some of it are like repetition of words. If we see things like stuttering or self-editing during reading, or maybe you're reading something that was not displayed, so we have to like remove all of those. And we removed if you have breathing or turbulent noise on the microphone, or if you're like singing, I mean, it sounds funny, but yeah, some people are like singing background, or like there's a lot of noise, and some people had a lot of repetition. And so we had to like remove all of this information. And that's why for our first phase of the project, we had 1,615 samples, but when we did all of this audio cleaning and post-processing, we were able to narrow it down to 919. You can access the data. It's on Zenodo, and you can also share it. We hope it will be useful for your research. Let us know what you think. Let us know how you think we could improve it. We're open to collaboration. And just to go to the second part, which I'll be talking about this morning, is Salty Translate. And for this one, we are still in the modeling phase, but we did a small demo, which I thought might be interesting to give a sense of how we're thinking about this translation process. For that, we're focusing on a paper called Foreign Accent Conversion by synthesizing speech from phonetic posterogram. We found their work very closely related to what we're trying to do, and I'll give you a brief overview. So what they aim to do in the paper is to generate speech that sounds similar to a given non-native speaker, but with the accent of the native speaker. So here, a non-native speaker would be, say, a Nigerian, myself, born, raised in Nigeria. And a native speaker would be, say, an American, like that speaks English fluently, knows all the rules of the language. So what they want to do is that they want to generate a speech in this non-native speaker, this Nigerian voice. They want to generate a speech in Nigerian voice, but with the accent of the native speaker. So imagine a Nigerian speaking like an American, so to say. So that's what the task of their paper, that's what they're trying to do. But what we are trying to do is in the reverse, right? We want this native speaker, or it can be an American, it can be in some other country. It doesn't have to be like someone fluent. It can be translating from an Indian accent to a Nigerian accent, or like from like within Nigeria, from Igbo accents to Yoruba accent. It doesn't really matter. But somehow we want to do the opposite of what they are doing. So here, during the training, they will pass the wave file to the acoustic model to extract the phonetic posterogram. Then they pass it to another model that does the PPG to male spectrogram conversion. Then they train another model, which is the vocoder, to be able to move from the male spectrogram back to the speech, back to raw waveform speech. So this is how they go about their training. For testing, you just need to have the L1 speech, that's speaker that you want to mimic their accent, or you want this other speaker's accent to be like. Then you pass that wave to extract their acoustic properties, and then you pass it to the synthesizer that has been trained on this non-native speaker, and then you do the conversion. So this is the process that they went about for their project. And luckily for us, they have pre-trained model, because a lot of these models are very hard to train. They take a long time to converge. So for the purpose of this demo, I just took their pre-trained model and tried to do some demo for that. So I'm going to play this American. So I downloaded a video tutorial. It's a lecture, but I extracted the audio and did the conversion.
Why would you get an insurance license? Well, I think a good reason is because nobody else wants to get an insurance license because they don't know anything about insurance. But insurance makes sense. It's common sense. You work your way through it and you say, sure.
Then now using their model, which was trained on some speakers, they also have a speech database. So they took the Indian accented speaker and trained the model on that speaker's voice. So I just took the model for the male speaker and did the conversion from this American accent to this male speaker. So the male speaker who has Indian accent is supposed to be sounding like an American now.
Why would you get an insurance license? Well, I think a good reason is because nobody else wants to get an insurance license because they don't know anything about insurance. But in short, makes sense, common sense, you work your way through it. Is it sure?
Yeah, so I don't know if you're convinced that the person does sound like an American accent. Maybe if you have heard what they sound like before the conversion, then it might be much more convincing to you. But nevertheless, you can see that the model was able to extract all of the phonetic posterogram that it needs. So it was able to, all of the phonemes or most of the phonemes which was present in the source accent was also present in the target. So it's quite fascinating, and we are looking at ways to build on top of this model, or also investigate other models that do similar thing. But in summary, this is sort of like what we are thinking of when we think of translation, right? We want to have a voice in like a tutorial or a lecture presented in one accent, and we want the user of our tools to be able to translate it to another accent that they feel much more comfortable with. But how exactly the translation, maybe it's matching the voice to the video, those are things that we are still investigating and still thinking of ways to better solve.
Why would you get an insurance license?
So I'm just going to move on to talk a little bit more about some ethical implications that we've been thinking about. We've all been aware of all of this, a lot of potentially problematic software being developed here, say deep face, or say like a lot of tools that can introduce fake news and everything. So we certainly don't want to add to that pool of problems. So we are thinking about the ethical implication, the potential for, say, abuse or manipulation or ridicule. Like, we don't want you to just change one person's voice or convert it to another just for fun or whatnot. We want to be able to retain all of the quality of the source accent, but just being able to change the speaking style in the best way that we can. So we're still in the process of getting formalizing this in this concrete form that would enable us to build a tool that will be used for good and not for abuse. So for our data set right now, we published it under attribution non-commercial because we're still developing the projects, and we want to make sure that we have a good paper trail of the people that have downloaded the data in case we have updates or something, so we can be able to track it. And so you can download the data right now. You can use it for research purposes, but it's not completely open at the moment to any other use. So broader impacts that we are thinking about, consistent with the motivation for the 4th and 10th sustainable development goals, because we all should we should all be working towards making sure that we achieve the sustainable development goals. The 4th one concerns quality education, while the 10th concerns reducing inequality. So we think that for students who prefer to learn in an accent that is familiar to them, our tools would be very useful for them to enrich their learning experience, which inevitably would improve the quality of their education, right? And if you improve quality of education, it means that it's one of the factors for good well-being of a person. It's also improve their level of income. So this would also contribute to unequal to reducing unequal opportunities. So this is what we have in mind when we're thinking about what kind of good that can come about from our project. So these are my team. It definitely takes a lot of team. We are open to collaborating with more people that have experience doing this, that want to also work on this if it sounds interesting to you. So please feel free to reach out. But these are my team, and I'm very thankful to them. So I just want to shout out to my team. And our work is sponsored. We are very, very thankful and grateful to be one of the grantees for the AI4D Indaba X Innovation Call 2020. So we are being funded under IDRC grant number stated on my slide. And if you want to read about the the progress so far. We wrote a report and it was published on the IJRC website, so you can have a look at that. And yes, that's all about my project. But before I leave, I wanted to give a short plug into the work we do in my community, ASS Lagos. We offer free to attend classes, and we've been doing that for the past 3 years, since 2018. And we are currently on our 7th cohort. We are taking classes on introduction to data science, to machine learning. These are the contents for the main class. You can find our structure on the link here. We are in our 6th week. By tomorrow, we'll be going over data pre-processing. All of our lectures are available online because of the pandemic. We moved our classes online, so you can have access to it. It's free for everyone, and we have a YouTube channel dedicated to that. I just wanted to quickly go over the link here. So this is the cohort 7 structure. You can see some details about what we want to what we aim to achieve by the end of the 16 weeks. And you can go to the classes on YouTube. You can view all of our classes so far. And also we have practical sessions. So you can also view practical sessions. The classes have their own GitHub repository. You can have a look at that. If it's useful for you, like maybe one topic is useful, you can look at it and use the resources. We definitely need to have as much resources as we can so that we can better improve our skills. And so these are all of them. Each class is being taught by different instructors. We are very grateful for their time. No one is being paid here, so it's just all volunteer driven. So thank you to my team. And you can also see information about the practicals. So that's it about my community and what we are doing. I will go back to my slide now and conclude. So in conclusion, we are trying to improve online learning experience. And the way we think about doing that is by translating from one accent to another. So far, we have built a web application to collect data. We have over 2,000 data samples, audio samples at the moment. It's open to anyone to contribute. Our goal is to create a database for African accents. But so far we have a lot of people from Nigeria because that's where I am from. That's where like the best way to get all of the people within my community to contribute. But this is open to you all as well. Please feel free to help us share that. And also we want you to join our team. I want to hear from you. Maybe you're doing similar projects that you think we can complement one another that we don't know about. We are open to collaborating. This is a big problem. And like as much people as we can have, the better, the merrier, the better. At least that's how I say it. So thank you, everyone. Questions? I'm happy to take your questions now.
Thank you so much, Ms. Teju, sorry. I've already shared the link for the GitHub and the links for the web app analysis that you spoke of, and the exit influence Google information that the participants can freely fill in. So it is in the chat somewhere. So far, I don't see any questions from the attendees.
Thank you so much. Thank you, Hannah.
But I wanted, okay, initially I had a question, but as you were explaining, it was answered, so it's fine, because it was on the issue of when you mentioned the whole translation issue on when someone with a totally different accent, you then translate it to the American accent.
Yeah.
But then you spoke on, keeping the originality of the person's dialect itself. So I was like, okay, then that's okay. Because people wouldn't want to completely give away the
definitely, Hannah. That this is something we've been thinking about. Like I have to tell you, like I spent lots of nights just thinking about this ethical, because I'm like, my research is in privacy and security, right? Like I definitely, like for a living, I look at problematic tools, and we don't want to contribute to that. But it's also a problem that I have felt so into, like I felt many times some accent, like I just don't understand this content just because of this, and it's a good resources, and makes me angry because it's not doing justice to the person that is presenting this thing. I just want to be able to find some connection between it. So we thought maybe we could do something about that. Certainly we are continuing, like we will continue to think about the potential misuse, how we can make sure that that doesn't happen. And you know, we are still working on this, and we are open to feedback, criticism, contribution. Well, thank you, Hannah.
Okay, so have you perhaps thought of perhaps, you know, at times some people's like the way they speak, it might not be clear.
Yeah.
So have you thought of then clarifying how they speak instead of actually translating it to a different extent?
You mean by asking the speaker to clarify?
No, I mean, perhaps aren't there any like models or something that can be used?
To models to make it more like to maybe some people do things like some training called accent reduction, right? Where you kind of like reduce the accent of it's a physical training when I was reading up on this. So are you saying that, like, you know, instead of completely like doing some translation, we let the model kind of like distill the accent a little?
No, not I don't know how to explain it, but I don't I don't know how to explain my question.
No, it's okay. It's okay. It's okay. But what you just said, I'm noting it down. It's like if it's what I'm thinking, then it's also an interesting way to go about the problem.
Oh, okay. Okay, thank you.
Yeah. Thank you so much. Any other questions? And I'm just looking at the chat now. Let's see.
I'm just curious, Teju. I mean, are there plans to do this for other languages other than the local languages in Nigeria?
Yes. I'm glad you asked, Maureen. Like that's the goal. Really, we want to. First of all, we want to the data collection. We want it to be in Africa, but you know, Africa is very, very big. When you say you're building for Africa, like you're not even touching like half of it. So that's why I'm here to share this project with everyone. And if you want to be a part of it from the different African countries, we can solve this together. So we want to collect data from different African languages, and we want to be able to build tools for that. But Nigeria is just where we're starting right now, because that's where I'm from. It's where I have all of my, like the most of the people that I know that can help us contribute to this. So the data collection, it's not just Nigeria. Anyone like can contribute to that platform as of right now. So please do share. And we're also thinking about like ways in which we can collaborate with, say, Mozilla and like some other. Mozilla is the one that we know that is very, very like championing this voice data collection. And we've been in conversation, but we've not settled on anything concrete. I just wanted to say that we are definitely very happy to collaborate and work towards a common goal. So if you want to collaborate with us, you want to do something together, please feel free to reach out and we can kick it off.
Okay, thank you so much, Ms. Teju. I don't see any questions in the chats. Once again, I'd just like to say thank you, and I'd just like to ask the attendees to just give a round of applause for your very insightful and very wonderful presentation. I already filled in the Google Docs. So
Thank you so much for inviting me and for allowing me to speak about this project. This is the first time I'm presenting our project to the wider audience, so it's definitely a big honor of mine. And as I've been mentioning, DSA means a lot to me. So thank you for organizing this and for inviting me.
Thank you so much. I think now we can actually move to the break session just for a while for people to just stretch before we can come back and finish off the rest of the remaining sessions that are about to follow.
How long will a break be, Anna?
The break is supposed to be, based on the schedule, it's supposed to be around, I think, 40 minutes, but I'm not sure.
We could take 10 and then come back at exactly 30 minutes.
Pardon?
If we took 10 minutes and then come back at exactly 30 minutes past 11, is that okay?
The time zones are not the same. So I think we should just take 10 minutes of and then come back again.
Yes.
Okay, so the break will start like from now. So 10 minutes from now, we're going to come back and continue with the sessions.
So we resume at
So in the meantime, while if the people that are going to be staying through the sessions can perhaps just share the experience that they've had for the past 5 days, either in the chats or decide to unmute themselves.
my connection must have broken there. I was saying that if you haven't, please take a look at the gallery. SPU was kind enough to find us some photos so that while we do the workshop, we're able to see a bit of Kimberley. So we have a gallery on our website. For the first time, I think we haven't had a gallery on an event website, but go visit it and take a look and see how Kimberley actually looks like. Get a feel of what we would have felt if we actually had gone there.
Maybe perhaps the participants that are attending this for the first time can share if it's like their first time experience or if they it's their second or their third time attending that data science Africa summer school. as like for me, it's my very first time, and I was very nervous, considering that I had to be a facilitator. I was nervous, but it's been a very wonderful experience, and I learned a lot.
Hi, this is Maxwell from Malawi. This is also my first time, and I've been trying to learn Python like for many years, but I couldn't start. But I think from the sessions we had in the summer school, at least now I can do some GIS, a little bit of data manipulation. So thanks to all the presenters for the excellent work.
Thank you so much for that, Mr. Maxwell. I don't know if apologies for that. Thank you so much, Mr. Maxwell. I don't know if anyone else would like to unmute and share the experience. And if not, I'll just like to add on and say that today it's quite hot in Kimberley. So if it was an actual interactive session, like the one-on-one sessions, it would have been really nice, because at least it's not that cold anymore, and people would have really had enough time to actually explore the place. And like when it's cold, you don't want to go out and see the scenery. There might be a next time. Who knows? Maybe next time there might be an opportunity for actual one-on-one interactions. So you never know. And we also definitely appreciate the comments coming in the chat section for those that are not, those that cannot unmute themselves. So please, if you have anything to say, do drop them in the chat section. I don't know if perhaps the presenters could maybe have something to say about the experience, perhaps not only for today, but or if they have been attending for the entire week. Okay, since the time slot for the break has finished, so we can then move on to the remainder of the sessions. I see that Ms. Kathleen is still not here. I don't know if we should continue with other sessions or not. Ms. Maureen?
Thanks, Hannah. I don't know. Catherine is still not here. I was just checking in the chat. I haven't seen. Okay, so if Catherine is not here, then I can actually go next. So I think mine was the next one. So just give me a minute and I share my screen. Hi, everyone. It's me again. Okay, slideshow is just taking its time. Cool, I believe you can now see my screen. I'll turn off my video because I do not trust my internet very well. Okay, so I'm going to talk a bit about my research that I am doing under the Data Science Africa Visiting Fellowship Program. And everything that I am going to talk about really has been under the brilliant guidance of Jessica and Professor Neil. Jessica is the Executive Director of the Accelerate Program for Scientific Discovery, and most of you probably know Professor Neil, who is the DeepMind Professor of Machine Learning, both at the University of Cambridge. They have been my advisors, my help in every way throughout this project. So I just had to first say that. Yeah, I've just seen Professor Neil is on call. Thank you for joining for my presentation. And yeah, so let me get into the topic. Hannah, please, at any point, let me know if I'm breaking, because I really know that for sure today my connection is not good. So I want to give a bit of context. And so let's define data sharing in this case as a practice of providing partners with access to information that they cannot access in their own data systems. So in this research, really what I'm trying to do is look into ways of making data more available to those that can optimize it to generate consumable insights that can aid sound decision-making and drive innovation. That would be like what I'm interested in doing, in what I am doing already in this research. And one may wonder how I intend to achieve that, but hold on just a bit. We'll get to see how I am going to achieve that. But first, for this to happen, for the kind of ideal data sharing for Africa to happen, there is a need of like sound data ecosystems in which a number of actors can interact with each other to exchange, produce, and consume data. So what you're looking at is a simple word cloud that was generated by Global Partnership for Sustainable Development Data during a project that they call Data Values Project, and they asked the participants ideally to, in one word, describe what an ideal global data ecosystem would look like. And those are some of the words that the participants used. I would say that for me, I think my favorites, or what I think would make an ideal data ecosystem, is impactful, collaborative, and enabling. But at this point, I just want to ask you, the participants, just if you could share in the chat two of your options, what you think from what was discussed. I'm putting the chat on the screen so I can see your answers. what you think would be ideal to make Africa's data ecosystem, to make an ideal data ecosystem for Africa. Just in 1 minute, if we could put our suggestions, 2 of them are good. I'll continue once I get about 5 answers. No, you can choose from the ones I have on the screen. Yeah, from the ones I have on the screen, but for Africa, because this is a global data ecosystem. So for Africa, for us, what is more important in your opinion? Is it inclusive? Is it ethical? Is it fair, balanced? You know, such. That's what I'm talking about. I'm just answering the question that I'm seeing in the chat. Thank you, Maxwell. I see value, trustworthy, collaborative, and everything, and engaging. Teju, you gave extra. Thank you. Great. So thank you very much. So useful. Thank you, John. So I think we all realize that we really need ecosystems that provide an environment for creating, for managing, and sustaining data sharing initiatives. And as you may know, despite the fact that the data ecosystems are gaining importance, there is no common agreement on what theories should, what it should look like for a functional data ecosystem, especially for Africa. And I can say that that was my motivation for my research topic that I chose to do under the data science visiting fellowship. So at this point still, I want to first sort of go back and tell you about how did I get to this. So what you're looking at is Africa's personal data protection regulatory landscape as of 2019. So out of the 54 African countries, 24 have passed data protection laws. And by 2019, when I looked into this, the latest was Uganda, Nigeria, and Egypt. And other countries have introduced the data protection bills, but they are still probably under discussion or waiting to be passed as by the legislative agenda. And others actually do not have any data at all, as you can see, which is the ones which I would say are in gray, as you can see in the map that is on the screen. So in 2019, I picked interest really in understanding the status of data protection and privacy in Africa. And I wanted to understand, okay, what can enable proper and effective sharing and use and reporting of data from both government and even private sector. So I had an opportunity to have a chat with Dr. Shira, who by now I believe if you've been attending this event, you know. And by then I was just sharing a bit about some of the work that I was interested in doing around probably a number of things. If you know me, I can be, I don't want to use the word talkative, I'll use elaborate. I can be a bit elaborate. So I just ran by him a number of things that I wanted to do. And somehow in his conversations with Professor Neil, he mentioned rather something to do with supporting Data Science Africa members to do such research. Somehow came up, and that's, without going into much detail really, that's how the DSA fellowship program has come up, and I happen to get the great opportunity of being the first one to be the visiting research fellow. I think I'm bringing this up at this point just to help all DSA members on this call and those who have not managed to join to realize the opportunity that we have with the kind of network that we have under Data Science Africa. And it actually helps to be open and share your ideas in this network of great people that we have in that Data Science Africa network. Like Teju was saying, I am very, very proud of Data Science Africa. And so, yeah, I'm just bringing this up to to probably encourage someone to share about their ideas. So moving on back to the research, I call this the COVID opportunity. And yes, I realize I've written the word opportunity next to COVID-19, which in my opinion should never be put even in the same sentence. But there has been some nice things that have come up because of the fact that we are in a pandemic. So what you're looking at is a global innovation startup map. And I know for sure that most of us have noticed that the urgency of the COVID-19 crisis has been a major catalyst for creative and novel approaches to data access and data use, with the aim of supporting decision makers to make fast decisions and decisively. So that is what I want to call the opportunity. So we know that really, as you can see, that is a global map, but you can see that even in Africa, African countries have developed and are still developing innovative use cases of data and statistics in which they are doing a number of things, for example, ranging from monitoring the extent of the disease spread among populations, or estimating the prevalence of COVID-19 and understanding the symptoms of COVID-19, because we all know the confusion that has been about symptoms of COVID-19. And then also even investigating how different policy interventions have affected businesses, livelihoods, and economies, among other things. With all that we have gone through, a number of people have been developing innovating solutions. And some of these, a significant number of these, as you will see in some of my findings, are actually data-driven, which has created an opportunity that, because data has been a basis for most of all, most, if not all, really sound public health actions, there is an opportunity to learn from the use cases and see, okay, so what has worked, what has not worked, and what can we carry on that can help in increasing data sharing, even for further social good other than just the pandemic. So what you're looking at there as well is areas that have been really impacted by data during this COVID-19 pandemic. So one of them being the population, because there's been quite a number of innovations, data-driven innovations, that are monitoring the extent of the disease spread among populations, understanding who is most at risk and how to allocate resources effectively during the pandemic. And then also the other area has been tracking of impacts. We know we've had a lot of lockdowns, and so that has led to business closures. How has that impacted the economy? How has that impacted agriculture and production and different other things? And also investigate, there have been many investigative applications and looking at how different policy interventions have actually affected livelihoods and economies, among other things. Then the other thing has been, of course, virus monitoring, to see how, to estimate the prevalence of COVID-19 and understand symptoms, like I have already said. And then also there have been many innovations and data-driven ones at that, under the health infrastructure and staffing, trying to understand, okay, what is the need, gauging the needs of health facilities and the staffing, and many more other innovations. I wrote about these in an article that I recently, probably a month ago, put on the Data Science Africa blog. I'll share the link below. But these are some of the areas that have been impacted by data during COVID-19. So from that, from the analysis that I have done so far, I have identified 4 areas of opportunities from Africa's data-driven COVID-19 response. And the 4 areas are actually around data, skills and expertise, policy interventions, and then barriers to effective data sharing. Now, under data, we're looking at exploring and examining the data sets and the data access strategies that have been used. So yes, we have noticed that there is an increase in the number of data-driven solutions that have been developed for COVID, which would definitely imply that there has been some sharing and exchange of data going on. So in this research, one of the things that I'm looking at is to explore and examine the data sets and see what data access strategies have actually worked. Then when it comes to skills and expertise, here, what I'm looking into is what skills and expertise are actually needed for effective collaborations. And effective collaborations here we can define as being those that have the project successfully had access to data and was able to actually be effective in the work that they were intending to do. Then policy interventions that have enabled more effective data sharing for COVID-19. And then can this be replicated to enable future data access for social good? And this is going to be across different countries, in as many countries that I can get stakeholders to work with as possible. And then finally, the other area that is an opportunity is actually the barriers that have been effective with data sharing, because that have affected data sharing rather, because by learning what the barriers that people interface during their process of innovating or using solutioning with data, then we are able to find how can they be overcome for future work. So this is not everything that can make data sharing possible, but these are the areas that I've noticed from the data that I gathered and analyzed earlier this year. So from that, then I was able also to extract what are some areas for action that, if my research can speak to these different areas, will be able to actually bring about or foster data sharing in Africa. And in that, we have data stewardships, technical skills and expertise, policy, collaborations, data and data ecosystems. I'm not going to go deep into all these because I wrote about them in this article that that was published in August on the Data Science Africa blog. So the link is there in the presentation. I'll share it. You can please take a look if you really find this project of interest to you. And at this point also, I wanted to mention that the Data Science Africa blog is actually open for the data science community to publish and write about your work here. There are guidelines on how you can do that on the blog itself. So please visit, and if you need to publish anything on there, feel free to share it with following the instructions that were given. So where am I in the timeline of the project? So I started earlier this year. I started with collecting data about Africa's data-driven COVID-19 solutions. The way I did it was I put out a survey and had people who had worked on solutions based on data to fill in, answer a few questions. And then that was one of my data sources. But then also I did an extensive search online to see all innovations that have been done, and then specifically narrowed down the search to those that were actually based on data. And after I did that, again, also this article summarizes my data set as of August. I know I have received not much, but a bit more data since then and now. And that will be in my next output, which I'm not sure what it will be. It will be an article, it will wait for the data sharing framework that I intend to develop at the end. But yes, there's still a summary of the findings that I have that I've found so far in the data that I collected. And now, after that process, my next stage in the project has been stakeholder identification. Now, who do I call stakeholders in this project? These are people who are, let's say, data scientists, policy makers. These are NGOs or enablers, literally, who have been working with data to respond to COVID-19. So while I was doing the data collection and then also doing the searches, I was also actually identifying who are the people who have worked on these projects, who are the organizations which have been impactful in the different African countries, which are the projects that have actually been taken up by various countries. And with this stakeholder identification, what I have done is I am organizing a focus workshop. And in this focus workshop, I'm going to convene those stakeholders that I've already talked about. And the goal of this workshop really is to sit, well, I want to call it sit around the table, but it's going to be virtual. So yeah, but yeah, a virtual table and share experiences, then be able to identify challenges, and then also explore what strategies have actually worked for these different case studies. And then that is going to be a huge part of my research to inform what has worked, what has not worked, what can be done differently. And those are going to be the bits and pieces of the data sharing framework for Africa that is going to be the outcome of my project. So the workshop I'm organizing is actually happening in a week, I think it's a week and a half, 20th of, did I put September? Oh, wow, it's actually October. 30th of October, yes. And so with this, I will be able to actually have a conversation with people that have worked with data, with people that have interfaced with different governments and try to access data sets that originally were almost not even negotiable. No one would talk about accessing such data sets, and see again what has worked and what has not worked. And the next stage in the project will be actually now to do the data consolidation and then finally finish my data sharing framework. So I don't want to go so much into detail, but I have done quite some work in documenting the project. So these are links about the project background. I have a project pitch deck that I've put together to sort of interest people that have been working on different projects and interest them about my project, for them to actually want to attend the workshop. And it has worked because I have quite a number of people for the workshop. And then also I have that article that I already talked about. And then if you want to learn more about the Data Science Africa Fellowship Program, I've also put the link there. So thank you. That's what I wanted to share about the project that I'm doing under the Data Science Africa Fellowship Program. And those are my contacts if you need to get in touch for any reason. Otherwise, I can welcome questions now.
Thank you so much, Ms. Maureen. That was a wonderful presentation. So far, I don't see any questions. Maybe perhaps people might be typing. And for those that do feel comfortable to just unmute their mics, can raise their hands, and then they can unmute themselves and ask the questions.
Okay, I see, can other members of DSA community attend the stakeholder meeting if they have worked with government data? Yes, and for that, you can write to me. Yes, I think, because ideally, because I want to make it a highly interactive session, I'm trying to limit the numbers. And so, yeah, I'm happy to, if you write to me, I'm happy to interact and indeed have you attend the workshop if it is possible. So I'm just gonna put my email in here. Who will be the primary beneficiary of my work? So the way I see it, it's actually quite a number of people. So first of all, even the data science community itself is going to be able to benefit from this, because then it's the research is going to be able to outline different approaches to actually accessing different types of data that have initially not been able to be accessed. So the data science community definitely will benefit from this research. And then also policy makers, because so one of the things that I intend to have as part of the output in the framework is going to be sort of like checklists. If it's let's say a company that is considering maybe we can share data or not share data, there's like a checklist of some of the things you need to check if your data maybe is shareable, if it's in a state that is if there are some details that you need to take care of before you share it. So like checklists of things so that you're able to check if your data share. Okay, I'm trying to compose a sentence here. It's not working. But like, yeah, if you're in a state that you can share your data with others. I hope that answers your question, Tina.
There's another question from Ms. Dina again.
Okay. The one other than the one of who will be the primary beneficiary? I thought that's the one I've answered.
Apologies.
Yeah. All right, thanks. So I think if there are no other questions, we can go, well, we can check with Chisenga if there are other, if the members of the panel are on call, and then we start the panel.
Okay, it seems that we're all here. I can see Selena, Trisha, and Martin. So I think we're ready to get started. So if you three could just unmute yourselves, just so that I can see you popping up to the top. And Trisha. Okay, great. So everybody's here now. Thanks a lot, Maureen. Thanks everybody for still being here. Obviously, it's been a really long week with lots of fun events, but as Maureen was saying, it's also really difficult to continue participating in virtual events like this sometimes. So kudos to all of you. So we have a panel right now, which is going to be about women working in data and technology. And we also have a male ally, Mr. Martin, who's joining us. So I'll just introduce the panelists and then we'll get going. So it's going to take the form of a discussion. So if you have any questions that arise as we're talking, you can just pop them into the chat and then we'll go through them during the question and answer session at the end. So we have three wonderful panelists. The first one is Trisha, and Trisha is an award-winning data from South Africa, based in South Africa. She's also the Senior Data Product Manager at Code for Africa, and she manages Code for Africa's Data Lab. She's also a coordinator of Wana Data, which you heard about yesterday, which is a Pan-African network of female data scientists and journalists and technologists. And then our second panelist is Selena Lee. She's the CEO of Zindi Africa, which is, as you've also heard throughout the week, we had Amy on the call earlier. So Zindi Africa is the first data science competition platform of its kind, and they're doing lots of wonderful work. And I hope some of you guys have been able to log into the competition that we have for this week and try it out. Selena also works and is passionate about data for social good, and she has a proven track record of thought leadership that's at the intersect between data and development. And then we also have Martin Mubangizi, who's a data scientist and the officer in charge of the UN Pulse Lab in Kampala. He's also the chair of Data Science Africa in Uganda. And you heard from Shira as well that they're working towards setting up a chapter. So Mr. Martin is working really hard on that. And he's also done loads of interesting projects, which have to do with increasing the use of alternative data sources and data science methods and AI tools to measure SDGs. Great. So if you're all ready, I'll just start by asking you to share a little bit about some of the work that you do. So maybe starting with Selena. So we've heard about Zindi so far, and Amy mentioned earlier in the week that there are 25% females registered on Zindi compared to 15% on other such data science platforms. So what do you think are the factors that contribute to this? And in your explanation, could you also tell us a little bit more about the impetus behind creating a platform like Zindi?
Sure, thank you so much. And thank you everyone. It's really a pleasure to be here. I'm such a huge fan of Data Science Africa, and congratulations to all the participants who are here this week. So thank you to Senga. Zindi, I guess you understand that Zindi is a platform where we host a community of data scientists now at over 30,000 data scientists that are solving real world problems. Everything from natural language processing to forecasting to computer vision, all types of, I guess, real world AI-driven solutions that are relevant to the continent. And so you asked about the composition of the community that's on the platform. Yes, I mean, we're so excited that we now sit at 25% female participation on the platform. I think in the earlier days, we were under 20%. And so over the last year, we've actually started to inch further and further. So 25% is great. It's of course not where we want to be. We want to be at 50%. But I think that some of the things that we've done over the last year to really encourage more women to come onto the platform are things like, are based in recognizing that, that what we want to create at Zindi across the board is a more inclusive AI ecosystem, and recognizing that everyone is coming from different backgrounds, different different profiles, and we want to create a space that is safe and welcoming to everyone. So that's kind of the underpinning. And so realizing that we were sitting at about 20% female participation, we started a few initiatives like mentorship programs specifically for women. We also started to we've done a couple of competitions on Zindi where we had prizes that were specifically for the top women, which was really fun, because then you started to see women meeting each other, whereas where they're so underrepresented on the leaderboards, usually on Zindi, I think we started to see women actually reaching out to each other and meeting each other through these competitions. And of course, through the mentorship program, there was a lot of networking and really great relationships that were coming out of that. And I think overall, I'm one of the co-founders. I have one other co-founder who is also a woman. And I think that just through pure representation, we've also been able to, I guess, be more sensitive to some of the challenges that women have. And then also, I think a lot of women feel more comfortable reaching out to Zindi and reaching out to us because just for representation.
Yeah, thanks a lot, Selena. That's really amazing. So maybe I'll ask Trisha as well to tell us a little bit about your experience coordinating Wana Data, and if any of the things that Selena have said resonate with you in terms of just trying to encourage more women to use data and to participate in these sorts of initiatives.
Yeah, so Wana Data, the network is a group of journalists, designers, technologists, and we want them to come together and work together from different fields. We want to be the facilitator and have them work together to do research, design, and create storytelling with that. And right now we have over 500 members, and we have monthly meetups as well. So they used to be in person, but now they're all virtual. And yeah, anyone can join this. We also often, when we have projects, we often have a component of storytelling to that. And the funds that we now distribute go towards Wana Data Fellows. So we'll put a call out, we'll have people now pitch their stories and give out these funds. Yeah, so we try and encourage the participation as much as possible. We tell them, even if you've been awarded elsewhere a fund and you need support from us, we're here to support you. Because a lot of the time, so we mostly work with journalists. So a lot of the time they receive funds for a story, or they've been awarded a fellowship. but they don't know how to go about, actually doing a data-driven story, and they really, become now under pressure. And so we make it open to them, saying that we're here to support you, we're here to help you and produce stories. And some of the investigations that have come out are really good. We have some women that, go ahead and like get further jobs afterwards and receive awards and all of that. Yeah.
Great. Thank you so much, Trisha. And the details of how you can join Wanadata, participate in Cindy as well will be provided, but I'm sure we already have them, but we'll still pop them in the chat later. So maybe now I'll move on to Martin as well. So we've talked about how Cindy have specific projects and activities that target women, and how Code for Africa also has a Wanadata program. But you and Pulse Lab and in your involvement in the Data Science Africa Uganda events, that may not necessarily be the case, but could you tell us a little bit if there are any ways that you yourself have been involved in trying to increase participation of women in these spaces that you're involved in?
Thanks, and I'm happy to be part of this panel. Yeah, so we've, as Shira mentioned in his presentation, we are trying to replicate Data Science Africa, at the country level, such that we're able to engage as many people as possible from the local universities, but also from private sector, from the NGO world, the UN, and also government. Because we think maybe one of the issues why we don't have very many females in the area of data science in Uganda is because we have, still a few number of data scientists. Generally, because we like at the universities in Uganda, we don't even have courses like a bachelor's course or undergraduate course in data science. And so we are doing very many things, deliberate things to ensure that we grow the number of data scientists in Uganda, but also make sure that we have a number of female data scientists in Uganda. Now, one way we are trying to do that is by role modeling. We deliberately encourage private sector companies that give us presenters, to give us female data scientists to present in our events. And we are happy, for example, with Stanbic Bank Uganda, that has always given us a female data scientist to present about doing how they're using data science in the banking sector. But also when it comes to moderators, of the events, we make sure that we have, we have female moderators. I mean, we have a balance. And we also are thinking of mentorship, and we can actually see the result of mentorship. You've had Maureen present, and she's on a fellowship, and she's really being mentored, and she has really improved greatly. Now, I also wanted to, on the side of the UN, I also wanted to bring out some issues. Now, recently, the United Nations Secretary General launched a report called Our Common Agenda. And this agenda is agenda of action designed to accelerate the implementation of the existing agreements, including the Sustainable Development Goals. And this agenda spells out 12 commitments, and one of the commitments is basically around gender equality and gender parity. And this is that it states that place women and girls at the center. So, and when we normally talk about gender equality, sometimes people tend to look at only they tend to look at the balance, 50 women or female and 50 male. But on the side of the UN, we think this is not enough, because there is need to look at all levels within the organization, and to ensure that women are not on just the lower side and they are contributing to the 50%, but they are at all levels, of executives, senior managers, middle managers, but also at the transaction workers level. So gender parity is very important, as important as gender equality. So that's what I would say. Thank you.
Okay, thank you so much, Mr. Martin. And thank you also for emphasizing that when we see a lot of these statistics about the number of the percentages of women working in technology, working in data science, often those numbers are women who are working at lower levels and not necessarily at managerial levels. So thank you for bringing that up. And I'm glad to see that there's work that's explicitly going towards addressing this issue. So now I'll just bring it back to Trisha and Selena, maybe starting with you, Trisha. So you're managing a data lab, you're working as a senior data product manager and data scientist. But what are some of the barriers that you've experienced as a woman working in this sector?
So I think a big one for me is sort of imposter syndrome, if you'd call it. I feel that because I don't see many people that look like me, or many people that don't identify as a woman like I do, it kind of feels almost like, what am I doing here? Also, there's a lack of role models. So I feel that combined, you kind of like, okay, where do I navigate? Do I belong in the space? You kind of feel like, yeah. And since data science is relatively a new topic, and it's just been just like in the last few years, it's really taken off, but it's still in its infancy. Okay. So you don't find a lot of people just experienced, or women, you don't find a lot of experienced women in this field. It's mostly male dominated. So I think that's another problem as well, is that you sort of see a lot of male faces around, or those who identify as males, and then you don't see females, and then you kind of feel like, do I belong in here? Am I worthy to stand up against very much more experienced people? And with experience, you now become much more bolder and much more confident. So you, as a bit more of a junior person, standing up next to more experienced people, it now becomes almost like a barrier where you feel like you're not confident, and it kind of brings you down a bit, or it intimidates you. Yeah.
Okay, thanks, Trisha. And if there's anybody else in the audience who's experienced this, you can also type in the chat and type what are some of the ways that you yourself have overcome some of these challenges. But I'd like to hear from you, Selena, as well. Like, what are some of the barriers that you've experienced coming from your background in mathematics and computer science, and now being a leader in the sector as well?
Yeah, I mean, Trisha's mentioned imposter syndrome. I think I mean, that inevitably always comes up in these conversations, and because it's a very, I guess, common and real problem. And especially like you were saying, it's because data science is still a relatively, well, it is a new field. I mean, for the women out there, you'd be surprised. Everyone feels like an imposter in data science because you never actually feel like you have enough. You might be very good at the statistics and the math, but then you're questioning your abilities in coding. So I think that, data science particularly is a field where women especially feel very much like, it's always like, oh, but I'm not a data scientist. People are very scared to even identify themselves in that way across the board. And I think so, especially for women, where they find themselves even more underrepresented in this field, it's even harder for them to really own this space and feel confident And confident in their abilities. So I think that the barriers for women, there's a few that I guess two main ones that I would want to highlight. I mean, I'll get to the imposter syndrome, but the first one that actually Chisenga and I were talking about the other day a bit is just kind of the structural realities of life for a lot of women. I mean, within different cultures, you know, the implications of being a woman are slightly different, but I think across the board, I think all women around the world can kind of relate to that. You know, generally women carry a lot more of the burden within the home, whether it's taking care of your kids or taking care of your parents or your siblings, or even just the things that have to get done around the house. There was actually a study that showed that working women do on average 21 hours extra a week above and beyond their male counterparts of homework, of home-related work. And so I think, you know, one of the first barriers that women have is just finding the time and finding the space for yourselves to continue to upskill, build up your careers, do all those extra things that, you know, get rewarded in the work environment. You know, that, and so secondly, what I want to get to is that on the side of culture in the work environment, if you don't have enough women in leadership positions, as Martin is talking about, like if women are not in leadership positions, there's not necessarily going to be a lot of empathy for the realities of women's lives. So like I was saying, if you're doing a lot of work at home, is that actually appreciated? Is that actually recognized as a strength, as a contribution? You know, women are multitaskers. Women are able to do, are incredibly productive. I mean, there's certain, I guess, characteristics and things that come out of that extra responsibility that aren't necessarily recognized as strengths, unless you have, you know, a culture within the work environment that recognizes those things. So on the culture, I think that the most important thing is representation at the highest levels, is creating a culture that is welcoming, and I guess, you know, recognizing of women. I feel like when I first entered the workspace, and I don't often talk about it, but you know, you mentioned that I came out with an engineering degree and I went into the workspace, and I was in a tech environment where I was the only woman on my team, and a lot of the decisions were being made after work, where the guys would, you know, go to a bar and have a drink, and I wasn't really welcome there, but a lot of the decisions were being made there. So I think that there's a lot of you know, cultural aspects within the workplace that is very hard to solve without representation and diversity in the first place.
Yeah, thanks a lot for both your contributions. So now maybe recognizing both the challenge, the barriers from an individual perspective and also those from a structural perspective, how would you advise somebody who is experiencing imposter syndrome or who's experiencing some of the barriers that you've experienced to go about navigating them? And I think also, Trisha, you had also mentioned about having a supportive work environment. So could you also touch on that as well? Maybe we'll start with you, Trisha.
Yeah, just to add to something that Martin and Selena made mention of is, even though organizations and companies, and there's a big drive for employing women and getting your staff up to 50 or 75% of females, and you know, just encouraging girls in STEM and all of that. But what companies don't really do is that they don't provide a comfortable or a productive workspace for women. So a lot of women may choose to nurse their infants or toddlers. Are they able to provide care facilities or nursing facilities in their offices? Are they able to provide childcare, for example, if you need to travel for an event or a conference? Is those sort of things being taken into consideration? That's just something I want to bring up. Then in terms of how you can overcome some of these barriers, I think that often we underestimate ourselves, and you know, you may think that you are not an expert, but you are being called to work on a project, or you are being called to work, you know, speak on a panel, for example, because they think or they believe that you have the expertise and that knowledge, okay? So you need to be humble, okay? But at the same time, know that you were chosen for a reason, okay? And people, respect your opinions. Especially when you work in tech and data science, we work now with very agile environments. So there's a lot of collaboration as well. So, a collaboration between a technologist, between a data scientist, a designer. So even though I may not be a technologist and I may feel like, whoa, I'm so over my head when I'm sitting in this conversation, you work along them and you know your data part. I know the data stuff, they don't know the data stuff. So I think that helps us as well. So you just remember that the agile environments really help us to interact and build our confidence. So just remember that this is your field, you've been called on for your expertise, and but just always stay humble and don't get a big head now about it as well. Yeah, so you just have to find that balance.
Go ahead, Selena. Thanks, Trisha.
Yeah. I mean, I totally agree with what Trisha is saying is, as women, you do have to keep reminding yourself, you were given the job for a reason. You were invited for a reason. You have value to put on the table. It is hard to build up that confidence. Depending on the environment you're in, it can be quite challenging as a woman to build up that sense of confidence. But you do, it's good to keep reminding yourself of that. And there's some interesting, I guess, insights into like the different behaviors of women and men in the workplace, in the sense that there's a lot of studies that show, like, when there's a job description or a job advertised, men will look at the criteria and, oh, they fill one criteria, so they're going to apply. Whereas women don't fill one of the criteria, so they decide not to apply because they say, oh, I'm not going to get it, or I don't meet all the requirements. But men in the meantime are like sending in their CVs and just going for it. And then the other interesting one is the pay gap, the pay disparity. They've shown that it's actually not really because men and women are offered different salaries, but it's because men then negotiate and advocate for themselves for the higher salary once they've been offered the job. So you can see this trend that I guess we're speaking to, and that as women, you really have to be conscious about how do you advocate for yourself, how do you own that space, and I think part of it also is one of the things that I've found the most helpful is building out networks, is building out peers, other women who are in this space, so you can support each other, look for mentors as well. I think that, networking is actually, can help a lot in terms of, finding your feet in this world.
Yeah, great. That's all really good. And I think it's also really nice that here on Data Science Africa throughout the week, we've had all these amazing women who are presenting, who are talking about their work, but they're also participating and asking questions when other people are giving presentations. Whereas ordinarily you'd think, oh, if, I don't know, Maureen is a speaker, she must know everything there is to know about everything to do with data science. But there are also other areas where she's also asking questions. So I think that's a really good point that both you and Trisha and Selena have raised, especially when it comes to space, which is new and fast-paced, and it has to be constant learning. So related to that, so what are some of the opportunities that both of you have taken advantage of for you to be able to progress in your careers? I'll start with Trisha.
So when I first started off, I didn't know much about data science, and I kind of just stumbled upon this career. I started doing a lot of online courses for free. And one of my favorite ones that I still use up till today is Data Camp. They just one of my favorites. They have so many opportunities. And just try and attend webinars. And now because of the pandemic, a lot of conferences are online, a lot of webinars are online. So just make the opportunity to go on and do all of that. Yeah.
Yeah, I would second that. Like I also, like as I was looking into data science and machine learning and things like that, also took advantage of like Coursera courses and things like that. Another thing is, I don't know where everyone is in terms of their careers, but something else that I feel like is important is that if you're really passionate about something, if you love, working with data, or you love, some aspect of this career, believe in yourself, and it takes a certain courage. It can be very scary, but, find your way into it. Like, whether it's maybe, stalking someone on LinkedIn and trying to get that first opportunity, offer to work for free, or maybe do a project on your own, and then start to show it around to people, that you think maybe would be interested in. And I think that, you do have to be a bit creative, but I think that, as long as, you're motivated from a very deep place where you love what you're doing, I think that opens up all types of opportunities, all types of ideas, but I think a big one is to just be creative, just try to get something, whether it's through your networks or through doing it for yourself, or just keep hustling around it.
Okay. And now, so we've also talked a little bit about there being a supportive environment in the workplace. But what about when it comes to male allies? So there's a lot of conversation about male allies when it comes to gender equity, but what are the ways that men can act as allies towards women in this field? And I'll first ask you, Martin, what are the ways you think men can act as allies? And then I'll ask you, Trisha and Selena, if there are any things that you think male allies shouldn't do, so that's also said explicitly. So Martin, you go first.
Yeah, thanks a lot for that question. Yeah, so I would just like to give some examples of things. Like, because of my involvement in Data Science Africa, Uganda, a lot of friends and have reached out to me to ask me about, to ask me whether I could actually provide advice to their sisters, daughters, and I've done a lot of one-to-one on that, and I've encouraged them to actually attend our Data Science Africa events, but also other events. And the other thing that we are thinking of doing is to come up with a calendar that can capture all these things, so such that it's just a one-stop place that someone can actually go to find opportunities. Because I think one of the other things that one of the other issues is actually awareness of things. We have, for example, many people who have done computer science who can really switch to data science and do things, but some of them are not aware of even data science. So the idea is to have that calendar that we can popularize, such that people get to know about these events, about these courses, and so on and forth. Then also, what I've the other thing that I found interesting is when, like, the UN advertises a job, they do not accept a long list or a short list without a female. So they believe the job was not advertised well enough, and so that's why you don't have female applicants. So giving a chance until you have female applicants on your long list or short list, they keep on sending you back such that you do you do enough. So in that case, we also try to reach out to encourage female applicants to actually apply through the different networks like Women in Machine Learning. And today I've learned about other networks. I think I'll be posting the jobs too, basically to make sure that it's not because they are not aware of the job opportunity, but it is out there for them to apply. Again, I would say encouraging female presenters as we approach the private sector or other stakeholders to give us someone to present. In our event, we normally, encourage female participation. So I would say, and of course, the other thing is what also causes issues to women is sexual exploitation. So I think as a male ally, I wouldn't like. I would like to deal with those issues if they came up, because then it may actually bar some people in applying for certain jobs just because of such fears. Yeah, so that's what I would.
Great, thank you. And you raise a really good point. We'll come back to it in the Q&A because Dina has a question that's related to that. So I'll just pause that for now. But Trisha and Selena, are there any specific things that you would not like to see in a male ally? Starting with you, Trisha.
So we really appreciate the support, but we as Africans are quite blunt most of the times. So I know I'm the elephant in the room, I'm the only female, and I know that the male ally wants to support me, but don't go and say, because you're the only female, I want you to go and speak first. Please don't ever do that. That just makes you feel all that more uncomfortable, like support me, but you just don't have to say that. Yeah.
So it's a tricky line between being supportive and then now also doing it in a way that's sort of condescending and feels like pandering. What about you, Selena? Do you have anything you'd like to add to that?
Yeah. So, I mean, not what I wouldn't want to see, but what I would like to see, but related to what Trisha said is, I think what's really helpful is, I mean, aside from the actions are important, but aside from the actions, I really appreciate it, when men are able to kind of step out of their own reality, like their own experience, and take a step back and try to just have an open mind about the mind shift, about the, I guess, if you're in a meeting and there's one woman in the room and they're not speaking, they're not contributing, they're not saying much, take a step back. Is it because she has nothing to say? Is it because she's not keeping up? Is it because she's not capable? Or, or take your step, step into her shoes and think, okay, well, maybe it's the dynamics in this room. So help create space for her, and not because of a pity thing, but because it's the right thing to do. If a joke is made, I mean, like Martin is saying, if a joke is made or some kind of comment is made, whether or not there's a woman actually in the room, correct that person, speak up. I think that's the best way to be an ally, is to kind of internalize the idea that, even if it's not actually affecting me personally, exactly, how would I feel if I was in those shoes? So that's.
Yeah, that's really good. And then, so what would you change if you had to restart your journey into getting into data science and doing what you're doing? Or what advice would you give to your younger self? Anyone can start. Okay, Trisha, you start.
Okay, so me personally, when I was done with my studying, I was kind of like, I need a break. I'm not really interested in taking too much of short courses and doing online learning and all of that. I just need a break, okay? But I wish I had gotten into a steady habit of learning, like maybe set a goal that every month I need to do a course. Because when I started quite early on in my career, I would do a course like maybe one every few months. So whenever I felt the need, I needed to learn something new, okay? Just to fulfill a skill set I desired or fulfill a skill set I needed for my job, okay? The reason I say I want to develop a better habit is because the more experienced you become in your career, the more your workload increases, you know, and then it can become very demanding. So to balance both studying and working is quite difficult. But if you have developed that habit over, you know, like from the start, you then be able to balance them out quite easily. Yeah. And another thing is that I used to put a lot of pressure on being a data scientist, okay? Because at that time, there weren't even many courses at that time. It was just like this whole sexy career. And, you know, I was like, I need to learn how to code really well. I need to know how to do this and that. And so I really put a lot of pressure on myself to develop these sort of hard skills, when soft skills are also quite important that we forget about. We forget about project management, time management, things like this. They don't teach you at varsity. They don't have a course and tell you, okay, this is how you arrange your calendar. This is how you manage your project, you know, especially if you're coming from a STEM background. So that's something else I would tell myself as well, is to also look into, you know, the softer skills.
Great. Thank you, Trisha. Really great points. And what about you, Selena?
I think looking back, there was actually a trend where when I was younger and I would do maybe an internship or, you know, some of my early jobs, I felt like I was quite intimidated in those spaces. And strangely, it would always be right before I was done with my internship, or right that last week or two before I was leaving, that I would maybe go out to lunch with one of the women, or, you know, there would be some kind of going away lunch, and I would talk to some of the women for the first time. I mean, some of the, you know, the managers, or, you know, actually start to connect with them on a bit more personal level, only for the first time right before I was leaving, I guess, because I was less scared at that point. And then I would always think to myself, like, why didn't I do this sooner? Why didn't I do this when I first came? Because it was always such a positive experience. So I guess I'd say, like, while I would tell myself, you know, while it might feel scary, you know, I would want to be more conscious about trying to reach out to potential mentors, or, you know, other women in the workplace to connect with on a more personal level, just start to build up that social network, you know, in the workplace. Like, be brave and just try it.
Yeah. Overall message is to be courageous in everything. What about you, Mr. Martin? What else would you change if you had to start over?
Yeah, so like they say, you learn data science by doing data science. And for example, Data Science Africa has a lot of resources, so notebooks, and videos that we have actually generated over the years. So I think I would basically go back to, I would actually go through those notebooks and code. And the good thing is that some of those notebooks also have data sets, and what I would do is to, you know, to switch even different data sets using the same code to see, you know, and learn through that. But also, you know, kind of different methods. So if it is classification, I would try to put in, if someone used k-nearest neighbor, I would use logistic regression, naive Bayes, and the rest, just to make sure that I've interacted with lots of data sets, but also different models, but also try to understand the differences in these techniques. I think that would actually build me into a better data scientist. And of course, being actively involved in a network is also good, and in which network, one would be able to identify, mentors for guidance, and as other people on the panel have said, we could, it's better to plan, to have a plan instead of and a goal such that you work towards it. Otherwise, if you don't have it, then it will be very difficult to achieve anything because you don't have any set goal. And I think this time around there are lots of networks like Ndaba, like women in machine learning, and then there are lots of efforts of also producing data like Lacuna and the rest. So I think it would be good for people joining this field to take to make use of all what is available. But of course, I must say that when also things are overwhelming, then it is also confusing. People don't know where to go first, and that could also be could be a mess. And as Data Science Africa, we are trying to see whether we can come up with guidelines that people joining the data science field can follow. To follow such that they're not confused by the overwhelming resources that are available. Thank you.
Great, thank you so much. Those are such good and very practical pointers, and I'm sure most of the people who have participated in Data Science Africa, that's been something that all the speakers have said, that remembering that when you're participating in a webinar or a session like this, it doesn't mean that you have to grasp everything. So you shouldn't feel like you're not intelligent or you're not doing well because you have so much time afterwards to go through the notebooks, to practice, to try out the code. So thank you so much for saying that as well, Martin. So we can have some questions now. So we already have one question, which is very interesting because I think these are some of the more cultural issues that we can all relate to. So the question says, I find it very tense at work for single women having male allies that are married. I've witnessed conflicts between the professional single women and the wife of the male ally. So what advice would you give to single women who are working with married male allies? So that's for all of you, the panelists. And then maybe a related question is something that I've heard a lot, and maybe something that we've all experienced, but where sometimes you walk into a room, and this is in a Zambian setting, but I'm sure this also happens in other settings. And people in the chat, you can let us know if you've also experienced this. But I've been in so many circumstances where I walk into a room, and maybe I'm the only female in the room, and then they asked me to make tea. When there's, these conference rooms where there's tea on a little table in a corner, but then they ask you to make the tea for them and bring them the tea. So also, how do you handle?
Take the notes.
Oh yeah, so you're assigned to take the notes. So how do you handle those sorts of circumstances while acknowledging that there are these cultural expectations and even things to do with not just that you're a woman, but also your age? Do you appear to be a young woman? Do you appear to be a woman who doesn't have a ring on her finger? So people are making all these assumptions about what sort of tasks they can give you. And how do you wriggle out of those situations without also burning professional bridges? So anyone who wants to share, and also anyone from the audience, if you have advice or input, you can also pop it in the chat, or you can just raise your hand and you can talk. Go ahead, maybe.
The T one, it's the first time I've heard that. That's I can't believe. I'm so sorry that had happened to you. I know once I was at a conference with my so-called boss, and I was going to make myself a cup of tea, and I told him, would you like me to make you one as well? And he's like, no, I can make my own tea. So I guess the cultural and by the way, my boss is European, and I think that in an African context that may have gone a very different way. So I think in Africa as well, there is a much further way to go in terms of gender roles generally. Yeah.
Yeah, and I'll say I've definitely seen this and experienced that. I mean, the tea, especially the taking the taking the notes and doing the little things. It's always, you know, you're the only woman in the room, no matter what your title is or who you are. It's like it. Yeah, I don't, and I feel bad because it does feel like in a very, you know, we can give an ideal answer, you know, which would be to, yeah, I mean, to stand up for yourself or whatever, but in a very real way, like the realities are a lot of times you end up going with it. So I actually would be curious if anyone else has, what solutions other people have found. I mean, I think there are nice ways to maybe call attention to the issue without, making everybody uncomfortable. Like maybe there's a way to kind of at least point it out so that if it gets pointed out enough times, like people realize the unfairness of the dynamics. But also Dina's question, I mean, that's very real. I don't actually know how people would manage that situation.
Yeah, okay. So Dina, thank you for the question. And I think, it is an interesting one, but I think, I mean, I just want to give an example with how I handle things. I am always open to my wife about, the people I work with and I support. And if I think a male ally is very open to say, it always talk about, what he does at work openly, then maybe the wife would, would stop, thinking about other things. So I think it is about really openness and I don't know, once in a while, maybe, the wife could meet this other person such that, so I think sometimes women would, if they don't understand exactly what your relationship with this other person you're mentoring, then maybe that's where they would have a problem. But I think if there is clarity that, look here, I have a person I'm mentoring, and they're interested in learning this, and this is our goal. I think it would ease the tension. But if things are not clear, then of course there will be room for suspicion, and I think that would result into issues. But for me, I think if one is open, then it actually solves. It actually solves issues.
Yeah, I think that's really good from the male ally perspective, and them being open with their own partner. And I also think even us as the ones who are being mentored or who have a relationship with a male mentor in our lives, it's also important to also establish professional boundaries as well, because it's also important to establish professional boundaries and determine from the get-go, or at least think about what kind of activities do you think are acceptable, what kind of activities do you think are unacceptable, especially if you also have a partner as well. So I think those are all really good points. And are there any other questions coming from the audience, or anything that you feel hasn't been adequately covered, or any additional thoughts you have? Trisha said, just say, I don't know how to make tea. How would you say that, Trisha?
That's such a good one, though.
Just say, I don't know how to make tea, and just like walk away because.
I love that. I think, if I don't know if there's any other questions, but I'll just say that this last part, the point that Dina made, what Martin is saying, like this tea thing, for me, it's so important that that came up, because it's like, these are the realities. This is the complexity. You know, it's not so cut and dry, like, oh, women need to be empowered or women need to believe in themselves. Like, these are the real things that happen day to day. And then that we have to navigate as I guess, as a society.
And something else just to make mention is, if you put into the scenario, most organizations and companies, let's hope that most or all of them do have a dedicated HR personnel or HR team that can now deal with these situations. Don't let it escalate where your mentor, male ally's wife is calling you up on the phone or visiting your house or anything like that. As soon as an issue arises, just bring it up to them and make it very well visible to the company and the organization, so that can be dealt in a very professional manner. Because what I think as well is what a lot of women don't want to do is report cases, because they think that, you know what, they may lose their job, or that they may, it now becomes like may tarnish their, chance of getting another job, or, break that mentor relationship, and they may not be a reference for you and that sort of thing. But if women are being supported as much as, if companies are saying they want to support women as much as they are, they need to make it a safe and comfortable, environment. So I think that the HR personnel should be able to help ease the situation and help, make it very safe and comfortable for you. You don't want like all of this drama in your life ever.
Yeah, that's absolutely true. And Elaine says that sometimes you have to deal with the discomfort of saying, I'm not here to make tea. And that's perfectly okay. And echoing to what you've said, Trisha, as well, sometimes you also have to deal with the discomfort of being able to go to HR and tell them about these issues and bring them up. And I think that from the first time you do it, your confidence grows and grows and grows. And I feel like this is a similar situation that happened to me when I was in my first job as well. In the first year, I was terrified of saying anything because I thought, this is an amazing job, I'm going to lose the job. But eventually got over that and managed to actually have a conversation with somebody and realized, oh, all I had to do was advocate for myself and negotiate for myself in that way. And actually these people were very supportive, and they were able to help me deal with the issue and move on to the next level. So I think that's also a really important point, but also not to trivialize some of these situations and how sometimes it can feel like your job genuinely is at risk. But it also comes back to some of what Selena was saying as well about establishing networks even within your institution, meeting some of the women who are in management roles, because it's likely that they have also experienced some of these things in their career, and they'll be able to advise you and support you on how to go about it. Yes, Martin.
Yeah, the other thing I would like to say is that, there are gender perceptions that actually people use. For example, this thing of making tea and the rest. So in the culture, in our communities, we grew up with, there are some perceptions that people have and carry because of of the environment, because of the culture, because of the religion and the rest. And I think these perceptions need to be dealt with, because if they are not, then they maybe is actually doing it not that he wants to belittle you, but no, because maybe they don't know that actually, I don't know how to explain it, but the thing is, the way we talk to our children, the things we tell them that a boy is, is not supposed to do this, a girl is supposed to do this, all that affects how these boys and girls are going to relate to each other when they grow up. So I think it is a bigger problem in the community that we really need to focus on. I remember there is a time when I used to tell a colleague that I was helping my wife with looking after the kid, and to her it was strange, but for us by culture, by then it was, it's like when you're talking about looking after your kid, actually parenting, you say that you're supporting your what? You're supporting your wife. But it's not, if she had not, come up to say, no, but Martin, if that is your kid, are you helping your wife? Or it is parenting. I mean, I had never thought about it like that, because every man would actually say, I spent the whole night helping my wife. The kid was crying and I wanted my wife to sleep, So it's not that he's doing it in bad faith, but just because, I mean, it's like normal, But when they are corrected, now they appreciate it. So there is also the issue of awareness, and of course, the way you respond to the person. Also, if someone says, tea, and then you should also do it politely and find a way of, educating the person, because also you wouldn't want to do it in a way that would actually affect his confidence. Yeah, so I think it is complex, but but we need to find a way of dealing with it. Thank you.
Thank you so much, Mr. Martin. I really like the point about how you often see men saying that they're babysitting, that, oh, I'm babysitting today, when if you're the father, you're parenting. So everybody should remember that and always tell people that you're parenting, you're not babysitting. Thank you so much for that. Do we have any other questions? Otherwise, we're going to wrap up the panel. If anybody has any additional questions, please type them now. Otherwise, you can always reach our speakers directly. And then for the panelists, are there any final takeaways that you have for our participants? Starting with maybe you, Selena?
Yeah, I think it's the things that I've been saying, but be brave, take those risks, and especially build up your support networks.
So I would say take up space, take up every single opportunity you have. Don't get too comfortable where you like, I have a permanent job, it's comfortable, I'm happy, Always strive to do better, to look for the next opportunity. Don't be afraid, take that risk. Another thing that I mentioned previously is that we often forget about the soft skills when it comes to data science. Okay, but now when we work with agile methodology, we work with technologists, product managers, project managers, journalists, whoever it may be. Especially if you're in the field of data for good or tech for good, the chances of you interacting with a community is very large. You need to be able to speak to people who are not who is not in the same profession as you. You may need to speak to rural communities. You may need to now explain your tool. You now need to train people on how to use it. You'll also maybe need to engage with funders, okay? And maybe even join like panels like this. So, get those soft skills, get project management, start public speaking, try and strengthen those other aspects that come in the field of data science and technology.
Thank you, Trisha. What about you, Mr. Martin?
Yeah, so for me, I think I would end by saying that let's place women and girls at the center, the commitment in the common agenda. And I would say everyone has a role to play. It's not only male allies, because sometimes there are situations where females don't help their fellow females to go up the ladders. So I think it is for all of us to try to place women and girls at the center and support them, such that their voices can be heard, such that we promote gender parity. We also look at maybe there could be laws that that discriminate against gender. We need also to deal with those. Then also we need to eradicate violence against women and girls, because that is also something that that actually may hinder women and girls to progress in the career of data science, but also in other careers. So that's what I would say. Thank you.
All right. Well, thank you so much. Over to you, Elaine or Hannah.
Thank you so much to the panelists. I wanted to say thank you in Chinyanja, but it went out the window.
It's Zikomo.
Zikomo Kwambili. Yeah, there it is. I must say that from my side as well, being a student that's doing BSc in data science, there's a lot of things that I wasn't aware of and that were brought to light. And I really, really appreciate the information that we got from this. Thank you so much. And I'd like the attendees to just please show their love in the chats by giving all of the panelists a round of applause. And as highlighted, I don't see any questions in the chats. So I'd like us to move to the next presenter, who is Ms. Afua Bruce. Ma'am, if I'm not pronouncing your name correctly, please do correct me. And her presentation is on the art of the possible. Over to you, ma'am.
Hello, thank you so much for the invite to join you all today. First of all, my name is Afua Bruce. You got the pronunciation exactly correct. I'm really excited to join you today and really just want to start by appreciating the previous panel. So much of what was said really resonated with me, with the importance of building your support network, leveling the playing field, trying to build equity for women in the workplace. Lots of things that I've definitely personally encountered in my career, lots of things that I have mentored some younger women in the field about, and certainly have benefited from a lot of mentors, both male and female, for myself. So that panel just really resonated with me. And I think that one of the panelists actually set me up well when you mentioned the need to develop some soft skills for working in data for good, because you might find yourselves talking with funders or talking with community members and needing to translate some of the hard tech that you're doing, some of the data science that you're doing into language and into words that resonate. That is what I spend a lot of my time doing. And I'm going to actually see if I can present some slides here for you. So give me just a second to set that up as we're chatting here this afternoon for you all. So my name is Afua. Again, my name is Afua Bruce. I am the Chief Program Officer at DataKind. DataKind is a nonprofit organization based in the US. We have chapters all around the world and are lucky enough to count volunteers on every continent except for Antarctica. We've been doing work for about 10 years and really looking to provide social sector organizations, so predominantly NGOs and government agencies, with data science support. Can you all see my screen?
Yes, ma'am, we can.
Great, thank you so much. So what DataKind does? So as I said, we work with social sector organizations. We work closely with them to really help define what their problems are, what their challenges are, and then see if data science or AI is actually the solution. There's lots of challenges in this world. Some of them can be solved through data science and AI. Some of them cannot. We never presume to we never want to be those people who are coming into a situation saying, we are technologists, we are here to help, we know your problem better than you do. Here, have our solution. We really seek to define problems together and really make sure that we are adding value and really enabling organizations to do their work better. From there, we go to our network of volunteers all around the world. We have about 20,000 volunteers we have about 20,000 people in our broader community, and again, all around the world. And when we identify particular projects, we're then able to go out into the community, into our community, and find the right data scientist for that project and make that match, and let both the volunteers do their work and then let the organizations benefit from that. And then finally, after we develop a solution, we try to stick around to make sure it actually works, to make sure the organization can actually adopt it and to do that work. So over the past nearly 10 years of DataKind's history, we've done more than 350 projects around the world. We have chapters in 5 countries, or we have 5 chapters in 4 countries. We've done more than 250 events around the world. We've donated about 250,000 hours of data science and AI services around the world. And so that's where we come from, and that's what we're doing. And this is just a visual description of some of what I've noted before about where we work, where our chapters are located, a couple in the US, as is our headquarters. And then we've got chapters also in India, in Singapore, and in the UK. We also do a lot of work in many African countries and many South American countries as well. Not so much in Australia yet, but that's where we're located. So over the past 10 years, we have developed what we feel like is a very good process for how you can go about doing work and doing work well when you're combining the data science and AI expertise with problems or challenges that communities are facing and community organizations are facing. And so this process that we have here, the 6-step process really goes through starting from really clearly defining the problem that people are facing, really articulating it. And when we have these initial conversations, we start from a place not of tell us where we can apply data science or tell us even the data that you have, but we really start these conversations by saying, you community leader, you leader of this NGO, what are the problems that keep you up at night? What are some of your biggest pain points? How are you functioning? How would you like to be functioning? And let's start from there and take your biggest challenges, then define what that problem is, then see if there's any data that can be created or data that exists around that, and then take it through this process. So a little bit more detail here, starting in that discover stage. And then we go into our design stage where we start to explore the data. And this is sometimes looking at data that the organization has. Sometimes it's looking for open data sets. Sometimes it is creating data. Oftentimes it is cleaning and organizing data. Every organization that can point to some type of data that they have thinks that it's the messiest data. And I assure you, every organization's data is messy. So cleaning and analyzing the data is really important. From there, we go through the process of actually finding the right talent for the jobs, and then working and executing, as we say, on the project itself, and making sure, again, in this stage, that translation piece of really making sure that you as a technical expert are talking consistently with community members, consistently with the leaders of government, NGOs, to make sure that you're designing something that they will be able to use and that's something that is relevant to their particular environment. Then again, we stick around to make sure that that transition from us as developing to the organization is smooth. And then we follow up about 6 months later, usually, to confirm that the solution was useful, or if it wasn't useful, we learn from there. But that's really our tried, tested and true project that we have. If you go to playbook.datakind.org, you can actually sign up and get access to our playbook that has these steps outlined in a bit more detail if you're looking to guide yourselves or some of your colleagues in this type of work. So DataKind, as we started by doing individual projects, and we do a project with one organization and then move on. Then we do a project with a second organization and move on from there. But what we realized at one point is that that's a lot of rework every time, and we weren't really building a body of knowledge. And just some of the challenges in the social sector space, especially, is that it's difficult to get started, especially when you're just building the same solutions over and over again, or you're rediscovering the same problems. And so we launched something we call an impact practice, which is just a thematic area in which we work so that we're constantly and intentionally learning what are the major challenges in this space, what are the types of solutions that are working, where can data science or AI actually have an outsized impact, and so is the right tool for the challenge that people are facing. And one of our impact practices is frontline health systems. And so we've launched into that. We launched this impact practice in 2018. And over the past few years have had conversations with over 100 organizations in this space. We've also, on top of having conversations, have done a number of projects with a handful of organizations here, a number of data science and AI specific projects here to continue to learn to also deliver value to those particular organizations. We also have been able to participate in different consortia in different learning communities for frontline health systems, particularly to make sure, again, that we are identifying problems that the people on the ground are actually want solved and actually need solved. And then we're in close collaboration as we are developing solutions. And as we've gone through this process, we've discovered that some things that we somewhat intuitively know, but now have a little bit more data to support these, but that it's really important that some of the challenges in the frontline health system space, particularly, are around increasing the amount of digital data available to then be able to do data science or AI, because we all know that one of the challenges to doing data science is having enough data and sophisticated data in order to do that. Looking at increasing the confidence in the digital data that's there, that it's actually accurate and useful, increasing the capacity of frontline health providers to use data and to use the right systems. And then, of course, the particular data science and AI tools that are useful to tackle some of these challenges. In our cases, we do a lot with risk modeling and predictive tasking. The problem, though, that we've honed in on as to where we're focusing of all of the problems that are out there, even some of the different projects that we have done in the frontline health system space, is really about how can we apply data science to improve data quality and data trust. And so what we've learned, right, are again, some things that are somewhat intuitive. You can't say that you're running data science or you're running AI and trust what comes out of those programs that you develop if you can't have confidence in that underlying data. And so we are looking at ways to, on system levels, really help improve the confidence in data, help improve data integrity, help identify errors earlier in data systematically and flag those, help to correct those automatically if needed, and more. Again, this is something that we have come to with all of our research. We're not the only ones to come to this conclusion. The UN has said something similar. And for those of you who work or touch frontline health systems, but honestly, a lot of systems understand this as well. I'm going to skip this slide and just go to some examples that we found. So we partnered with an organization that worked with a lot of pregnant women and early mothers. And so in looking at their data, for example, we found some inconsistencies, shall we say, some nonsensical values here, in that some of the data showed that they had a non-zero number of pregnant women who were 0 years old, which feels likely impossible, and then also had a bump in pregnancies in older women. So those types of looking at the data makes us think this is probably wrong. How could we build some systems that flag this information earlier, that correct for this information at the time of entry or within the system as you're making predictions and doing analysis. And so as we look at the different types of IOP or inconsistent or problematic data, these are some of the types of challenges that we are faced with and what we look particularly to do. We know that the types of solutions that we come up with must be implementable in the languages already in use. They must be integratable with standard workflows. They must support the creation of future reports and visualizations, especially, and more. So this is what we're trying to use data science to solve. And our model, of course, is working on individual challenges, individual organizations, but then really looking for opportunities to replicate the solutions from place to place and from organization to organization. Because I know some of you skew on the more technical side, I just wanted to include this diagram. I will share it afterwards for those of you who might be interested in this, and happy to chat about it a little later as well, or you can follow up with me after today. All right, and so that is at the macro level, sort of how DataKind runs our projects, how we got to frontline health systems work, and the types of challenges that we are looking at in frontline health systems and why that matters to us. And then I wanted to talk just real quickly about a specific challenge in a specific organization that we worked with. So this is a picture of some folks from Writers for Health. And we work closely with the Writers for Health OCR, or Rocker, which is a prototype for automating form processing and handwriting prediction tools to aid community health workers with more efficient and digital data collection. And so, essentially here, the big challenge is that frontline health systems teams or frontline health teams can carry really large information books with all of the information they're collecting. And it can be about 5 pounds as they're going around doing their work. And then it can take weeks or even months. In the case of writers, it was taking 80 days from the time someone would go and do a health visit, write it down on their paper, take it back, and finally get it inputted into a system. And then through all that process, there was a lot of errors that were inserted in the process. And so we were able to partner with Writers. We as DataKind were able to partner with Writers for Health and help automate that process, help to develop an OCR solution to digitize the collection. And we're then able to take this processing time from 80 days to just a few hours from the time people would be able to drop off their logbooks and manually get it input in the system, to using the OCR process to just digitally intake all of that information, flag any errors, and upload that into the system. So a huge time savings. It also means that any analysis that is being done is done a lot more quickly and a lot more accurately. So rather than, for example, if an outbreak of something occurred in one place and it was captured in the forms, and you waited 80 days to then be able to see that in the data, that's a lot of time and a lot of hardships on people's lives and health that you'd have to do. So really a lot of positive impacts seen from this OCR tool that we were able to partner with. So just a bit more on how we worked with them. again, just going from weeks and weeks to a number of hours for how to update their system. We worked on this project with Writers for Health for about 9 months, which is about how long a lot of our projects, our longer term projects take. And at the end of the process, the folks that we were working with were pretty pleased, as you can see here. And even more importantly, we've now found 2 other organizations, or writers in other place, another organization, who have expressed interest in this tool, and we are actively exploring how we could replicate the solution that we developed for Rocker, and how we can develop that and apply it for other organizations as well, which back to why we started with our impact practice model and how we think we can make a difference in the space is, again, let's not recreate the wheel every single time that we do this, but let's see what can be done. I'll also note that DataKind does try to open source a number of our solutions. We default actually to wanting to place our code on GitHub and make it available with some open source licenses. Sometimes the nature of the data that we've worked with, or the nature of the relationship that we have with our partner organizations, precludes us from doing that. But we do start with that bent of how are we communicating back out, and how are we sharing some of the tools that we've developed with the broader community. So if you are interested in learning more about our frontline health systems impact practice, again, I'll share these slides, and we've got a number of articles on the different projects that we've done in different places, and what the impact of those projects have been, a little about how they've been designed. You can also check out our GitHub to see what code that we've been able to make available. And to do that as well. And then if you are interested in getting more involved with DataKind, please follow us on any of these channels. You can reach out to me as well. It's just afua@datakind.org. We have a number of longer term projects that we recruit for every probably 3 or 4 months. Again, these projects do happen around the world. Our next call will go out in October, although most of the projects in the October call will be US focused. The call after that will have some projects, again, that are, I think, extending our work in Uganda and in Kenya. So keep a lookout for those if you're interested. We also have periodic events that we call data dive events, which are just weekend-long events for data science. We take as many people as are interested there, and we as DataKind work with organizations for a couple of months leading up to the event to really scope out the problem and to come up with task lists. And then at these data dive events, we are able to have people of whatever level of data science expertise you are, from I know nothing about data science, I want to learn, to I am an expert in all of the data science techniques. You're able to plug in and to work and to help support organizations from there, grow from our community and use your skills. And I think with that, I'm a little over time, so I'll stop there. I don't know if we have time for questions, but that is what DataKind is up to, how we do our work, and how we try and build places for folks to continue to learn and use their data science and AI skills.
Okay, thank you so much, Ms. Bruce. I currently don't see any questions in the chat section. Maybe just wait for a few seconds. Perhaps people are still typing.
Well, I love it if I give a presentation that is so thorough, no one has questions. Again, I know I provided you with a lot of information today. If you are interested in knowing specifically about some of our work in Uganda, in Kenya, in South Africa, in Nigeria, please reach out. Oh, I see now in the chat that Martin's hand's up, and I am sorry I missed that.
No,
so Martin,
yes, thanks. Yeah, thanks for the presentation. I know I had you mention Uganda, and being in Uganda and where we are trying to start the Data Science Africa Uganda chapter, I thought it would be interesting to meet your, basically to work with DataKind. Are you already in Uganda? Do you have some projects running in Uganda, or you're going to begin?
Yes, so we do have ongoing projects in Uganda, actually. One project with the Ministry of Health. I am scanning through the participants list because I thought I saw my colleague, Ms. Holly, who is on the line. And Tali actually is our portfolio manager for our frontline health systems work. And so she has really been leading some of our partnerships and relationship building with the organizations in Uganda that we've been partnering with for the past about 2.5 years now. So Tali, if you want to drop your, I'm putting you on the spot here, but if you want to drop your email in the chat, I think this perhaps is a good connection. And then Martin, we'd be happy to walk you through in detail what we're doing and also explore further ways to partner.
Okay, thank you for dropping your contact detail, Tali. I don't see any questions, so I would like to thank you once again, Ms. Bruce, for a wonderful presentation. And I see people have been showing their appreciation in the chats by saying thank you and giving you a round of applause. I'm sure indeed your presentation was thorough. That's why there weren't any questions. And on that, we'd like to welcome Miss Amy Bray for her announcement on the hackathon winners. I know it's something that a lot of the participants have been waiting for. So I think we could just welcome Miss Amy on that.
Hi, I'm going to quickly share my screen. I just want to say a massive congratulations to everyone who's new to Zindi and who were brave enough to register for this competition. I think that's an amazing achievement in itself. Another congratulations to everyone who managed to at least download the data and open up the starter notebook. In my presentation on Monday, I put emphasis on creating graphs and exploring the data over building a model. So I feel that that's the most important part about a data scientist and data analyst, is that you can really dig deep into the data. Congratulations to those who managed to make a submission and land on the leaderboard. An incredible achievement, well done. So this challenge ended 15 minutes ago, and in the next 45 minutes, the top users on the leaderboard will receive an email to hand in your code. Please do hand in your code so we can verify that you get the right score, as well as just to see what you've done and what you've learned over the past week. So without any further ado, here we have our winners. In first place, we have Israel Kings. Next, we have Mika D and Olayile from the University of Pretoria. I absolutely love seeing females at the top of our leaderboard because that's where you belong. So congratulations to everyone. Please keep an eye on your emails. Yes, short and sweet. So these are our winners, but positions on the leaderboard may change. This is due if people don't submit code or code's a bit different to what we expected. So I think everyone on the leaderboard needs to keep an eye on their emails in case you manage to work yourself up the leaderboard and you might win some prize money. Thank you, Hannah.
I'm curious to ask if any of the winners are actually on call.
That would be amazing. I'm gonna scroll through here.
Any of our winners on the call?
Olayile, you're here? Are you brave enough to unmute yourself?
Hello.
Hi, congratulations.
Thank you.
I know. Wow, congratulations.
Is this your first competition?
No, it's not. I joined, I think, over a year ago. So I've competed in a few of them.
Brilliant. Yeah, I'm busy seeing, I've just gone onto your profile and seeing how you've managed to work yourself up the leaderboards. That's amazing. Do you have anything that you would like to tell new data scientists, or how did you manage to overcome the scariness of competing?
I just, for the first one, I just took the dive and just did it. And then the discussions were really great, as well as because you usually have the presentations in the beginning. So those were also really good. And the starter notebooks are very helpful as well.
Brilliant. Olayile, I'm going to put you on the spot. She is number 3 on the leaderboard. So anyone who wants to send her a message and ask for encouragement or advice, I'm sure she'd be able to help you.
Thank you.
Congratulations. Hannah, over to you.
Okay, thank you so much, Ms. Amy. And I'm sure the rest of the winners, if they found out that they won, they would be delighted and over the moon. And finally, we're supposed to have closing remarks from the TBD team. I'm not sure, Ms. Maureen?
I think that's, I can take
Yes, please, like, go ahead and take a close.
Oh my. Yeah, I mean, it's been a wonderful time for the short time that I've been able to join. So I just want to thank everyone for making the time to join, for contributing, whether you ask questions or you give a presentation. Thank you for participating. It's been a long, wonderful week. And I hope if you're not already on the DSA mailing list, please join the list. We do send out opportunities. We sometimes have presentations and other things that you can participate in. So please join us. That's all I have to say. Just want to thank the organizing team, everyone who's still on, Maureen, Nontokozo, I don't see her, but and Shira, of course, and several other people who worked with us on this, and also all the moderators for moderating throughout the week. So thank you, and I hope to see you all soon again.
Thank you, Elaine, for the closing remarks. It's been awesome. I just wanted to mention that for the winners of the hackathon, please email our DSA email, info@datascienceafrica.org, and then you will be guided on how we're going to go about getting your rewards. Otherwise, congratulations once again, and again, thank you for staying all these days. So I guess, I don't know, I mean, the program is done, but I don't feel like saying the words of the end.
I mean, if you want to stick around and chat, feel free. Otherwise, we're done.
Thank you.